Okay. Thanks for coming to this tutorial, Python by Immersion at PyCon 2019. The survey link is here. Please fill it out afterwards. And the Jupyter Notebook link is there. It's a set of Jupyter Notebooks. I'll be running them individually because the one that has all the Jupyter Notebooks combined is really big and slow. I'm going to give you lots of information in 3 hours. You're not going to understand all of it. You're not going to remember all of it. You might start to feel bad because I'm going so fast and think that I should slow down. But my goal is, my thinking is, I will, like learning a language by immersion, I'm just going to show you lots of things. And my theory is, and I hope this is true for you, is that in a few weeks or a couple months when you're doing something and you go, oh yeah, I wonder if there's a function that, I'm sure, there's got to be a function that does, and then you'll be thinking of some problem you're trying to solve. And the reason you'll know that is because you saw it and kind of got a sense for the language today in over 1,000 lines of Python code that I'm going to show you. Okay, so this is a broad overview. Don't write down the details. They're in the notebook. You can look at them. The pattern is I will show you, I'll do a lecture and demonstrate some of the code and talk about some things, and then I'll let you do some exercises. Most of you won't finish the exercises. I will stop and move on when maybe half of you have finished in general, and you can go back and look at them. But I'm not just going to skip past. I'll actually go through the exercises and show you what to look for. When you're doing the exercises, you'll find that the ones later on are like they sort of ramp up sometimes in complexity and difficulty, because I want everyone to sort of, even those who are really fast with that, to still be engaged and not just sitting there twiddling their thumbs. When you do the exercises, and I'll remind you of this later, don't just hit Shift-Enter to see what it does. The point is, I want to help you learn to think about how Python is working, because if you understand that layer, then where you're working in Python, whenever you're working in any layer of abstraction, understanding what's going on sort of the layer below is really helpful. You know, if you're riding a bike and you've done your own maintenance on it, it's just going to work better. Same for other, cars, etc. I'm running Python 3.6. If you're running 2.7, you'll see a few weird things. I think that's all. Oh, and the last thing is the first 10 to 15 minutes, some of you might want to leave because it's going so slow and it's so boring and you already know it. It's going to get faster, okay? And I do that first part really slow intentionally because I want to, especially those of you coming from a different language, I want to change your way of thinking about how Python works from what it probably is, even if you don't know it, or at least it may be. All right, so let's get started with the actual stuff, the actual content here. So objects, let's just first see what version I'm running, Anaconda 3.6.8. Okay, so here's the first really slow, boring part. What happens when you type 1, hit the 1 on your keyboard, and then hit Shift-Enter in Jupyter Notebook or Jupyter Lab, or you hit Enter at the REPL, the read, eval, print loop, which, guess what it does? It reads what you typed, it evaluates it, it prints it out for you, the value of the expression, and it does that over and over again. That's why it's called the read, eval, print loop. It's the REPL. So when you type 1 and hit Enter, what happens is Python, and I'm going to show you this picture over here. Python goes over here in memory, and I'll sort of use this side of the room. This is like memory where Python has all its objects. It goes off here and it allocates a chunk of memory, and first of all, it parses that and says, oh, okay, I know what that is. That's an integer literal, meaning it represents an integer, and it's typed as an integer. It goes off and either finds or creates an object that represents the integer 1. I put 100 here, but the point is it represents an integer, right? And that integer is not just 64 bits in length, or depending on whatever hardware you're running. It's actually bigger because it's got some pointers to some other things. It's got a pointer here down to the type int. And it's got something over here which is which has a 1, which is the ref count. How many names are bound to that object. And I don't know exactly what's in there. I haven't looked. But the point is it's got a few more things. And these are the two that we'll care about. Then it it's done. It created the object. Everything in Python is an object. It created the object, and because it's the read eval print loop, it prints the value of that object. And so what you get back on the output is a 1, right? So that 1 right there where it says cell 3, that's in Jupyter Notebook, by the way, in case you're not used to it, the in is cell 3 and out. So the input, what you typed in, what you get back out. And what you get back out is a visual representation of the object or the expression, the value of the expression, which is always an object. Okay? So when we see 3.14, that's a float literal, I want you to think of all those things that just happened. Okay? Any questions about that? Okay. So you create objects in Python. You can do them with literals like ints and floats and strings and lists and tuples. Those are some of them basic types, not all of them. Everything in Python at runtime is an object. And it has a single value, it has a single type, it has some number of attributes, one or more base classes, a single ID, and it has some names. So let's look at those, and I'll start to speed up a little bit. So I'll go a little faster, but I'm going to slow down occasionally again. Oh, look, I'm going to slow down here. So type 1, what happens here is Python sees the name type, and it looks in something that's a lot like a dictionary with key-value pairs. And the keys are the names. Like somewhere in here it looks for the word type, the TYPE, the string. And if it finds it, then it dereferences it. There's the value. It goes and looks for the object, which the name type is bound to. And then it takes that object. It goes and sees the 1 and says, oh, I've got to go create or maybe reuse an integer literal. An integer 1. So it goes off and creates, maybe it goes creates another one, even though it threw, because it might have thrown the earlier one away. And then it calls the type object, which is callable, it's like a function, and it passes a reference, like the arrow part, off to that type function, and type does something, and then it returns a new object, or an object. And that object that gets returned is then displayed, that's the print part, okay? So what happens there is we get the letters INT, okay? Well, that's because INT happens to be a name that Python knows about, and so it shows it to you as the name. So it can't show you the bits in here, it shows you the name that it knows, okay? All right. So we can check the type, and what type does, in this case, you pass it an object, it returns what type the object is, right? So some people say Python is not a strongly typed language. It's not typed at all. It actually is strongly typed, very strongly typed, and it's dynamically typed, which means we don't declare up front what the type is associated with a name. Instead, we create objects, and those objects know their own type, and then we just bind a name to the object. So the name has no type information stored in it. The name only refers to the object. The object has the type information, okay? Name binding, which I've shown here as sort of the way it's implemented. A good way to think about that is post-its, right? So you can call me teacher. There's a post-it that says teacher, right? My kids call me dad. There's a post-it that says dad, right? My wife calls me husband or spouse or partner or Stuart or whatever. I mean, the point is I've got lots of labels on me, and some of you are probably dads, and your kids call you dad. They don't call me dad. So so the same name can be reused as long as the context tells you how it distinguishes it, makes it unambiguous. Okay, so let's look at the type of the string spam. It's str, list, tuple. Objects have attributes. Here's some examples, right? So attributes, in this case, true is a built-in name that references an object, and that object has a dunder doc attribute. Double underscore, DOC, double underscore is pronounced dunder doc. So if you haven't heard that, that's what I'm saying. That's what it refers to. So I can access the attribute of an object just by putting a dot and another name. So just like I have global names like true and print and type, and then we'll see how to create our own later. An object has its own set of names, right? So imagine a table like this in an object. So dunder doc is one of the names inside the object, right? Oh, so that's a long string with some new lines in it, looks like. I can actually print that thing, and you get the documentation. So when you look in the documentation in your editor and say, show me the documentation for this object, it's going to go and ask the object and display it to you. So the documentation for Python object is built into the runtime. All right, there's another attribute, spam.upper. Here we've got a less than function str.upper greater than. Those angle brackets are the way Python, it's the convention that Python uses to display an object where you can't type it back in, right? So this string, you could put that back into the REPL and it would create a new string object. The type tuple, the type of that tuple is tuple. You could type tuple and it refers to the object in the REPL, so it works. The function str.upper, you can't type that function in. It can't easily represent that function because it's implemented in C in a way that you could type it back in and make it work. So it puts the angle brackets around it. So that's what those mean. Okay. So this one is callable. All right. So what's going on here? All right. So Python sees the string literal, goes off and creates a string object. It uses the dot. The dot tells it, I want to get the upper attribute of it, so it goes ask the object for that attribute. Then it takes the object, gets back, looks up callable to find an object, passes a reference to that object, the upper function, off to the callable function, and it returns a new object, right? All this stuff is happening every time you do a simple little expression, okay? And callable is yes or no. Can I call this thing? And the answer is yes. So let's try to call it. And what happened there is the function returned a new object, the upper function, which is actually called a method because it's a call on an object, and it returns a new string, right? It didn't actually change the string SPAM to capital SPAM. That old one still exists or could. It creates a new string, okay? By the way, spam and eggs are sort of the standard junk variable names or variable names, and I'll use them in here because of Monty Python. Objects have base classes. This is the boring part. We're about halfway through it. Am I going too? How many people think I'm going too slow? How many people think I'm going too fast? Okay. And I'll revisit some of this. You don't have to memorize all this stuff. I'll remind you, maybe more than you want. Objects have base classes. So let's import the inspect module. We'll talk about what that does later. And we'll take the spam string and pass it off to type to get the type, pass it off to the getMRO function in the inspect module. Right? So I'm reading it backwards because that's sort of how it gets evaluated. GetMRO means get the method resolution order. In other words, show me if I call a method on an object of this type, what superclasses is it going to go look in to see if I can find it? Well, that tells us what the class hierarchy is for this object. And the answer is type of spam is str. str is a subclass of object. Object is the name that refers to the object in Python that every other object in the Python runtime, when you're running it, is a subclass of eventually. Okay, so it's the parent at the top of the tree of all the objects. Here's a more interesting one. Bool, so true is a type bool, which is a subclass of int, which is a subclass of object. How many of you don't know what I'm saying when I say subclass? Everyone knows about object-oriented at least a little bit. Excellent. At least a little bit. Okay. Every object has an ID. In C Python, I'm running C Python because it's written in C. It's called C Python. There are other versions of Python like Iron Python written in C# that works well in the CLR or DLR space on .NET and Windows. There's Jython written in Java that is a little bit stale. Still haven't gotten to 3. I don't know if they ever will. That's written in Java and works with, it compiles to the JVM. There's PyPy, which is a Python written, a lot of it in Python. That's a very interesting project that a lot of people use. And then there's a few others, Stackless, et cetera. Lots of implementations. Oh, MicroPython. I'm sure I've only named half of them, but those are the big ones I can remember. Anyway, CPython, written in C, when you ask Python to show the unique ID of an object, it shows us the memory address, which is an easy way to make it unique. right? So it's not guaranteed to be the memory address in every version of Python. And I don't think I've never used this because the only reason you would need to know the memory address is if you're writing an extension probably that's written in C, for example, and you need to pass pointers around. But usually Python handles all that, so we don't need to worry about it. We just know it's a unique ID. The only other thing that's kind of interesting is look at those numbers. You notice how the ID of 3 is relatively small compared to the ID of the other two? That gives us a hint about where it might be stored in memory. And we'll touch on that briefly later. Okay. So usually we create or access existing objects by calling something else. So here are some examples. Here's the ABS is the function which returns the absolute value. It is callable. If we call it with -3, it gives us 3. All right. Int is callable. If I call it, pass it a float, it truncates it. Okay. Okay. Don't look at this code. You don't need to know what it does. But I need to load it because it's the only way I could figure out, oops, sorry, to show you this easily. Okay. So what are the current names in my namespace? Nothing. So name, value, ID. The only reason I'm showing you the ID is because I want you to see that sometimes if two names refer to objects that have the same ID, well, they're actually the same object. So that's why I'm showing you the ID as well. All right. I'm going to slow down here again a little bit. So the way you've learned that computers work, computer programming languages work, many of you, not all of you, is that you name something like an I. You say, okay, I want to use a variable I, and I want it to represent an integer. And so the compiler says, okay, every time they use I, it's an integer, and I will remember that. It then creates a box big enough to hold an integer. Then when we say, or A, probably should use A instead of I. Anyway, if we take that I, then there's an assignment statement. So like in C, you'd say int I equals 1. Then what the compiler does is it puts, it makes it such that when the code is running, there is a box that has the 1 in it. And if you later say I equals 2, it takes the 1 out of the box, it overwrites the memory and puts 2 in instead. And when you say I plus 1, it issues a machine instruction, which is an integer add, which is different than a float add, because the computer needs to know, well, there's just bits in this box, what should I do with it? Because adding floats and adding ints are very different parts of the CPU and treat those bits very differently, right? So it has to remember what's in the box so it knows how to do things like add. Python doesn't do that. Python, the object remembers what type it is, and it knows how to add itself to a float or vice versa. It doesn't do it very quickly because it's not compiled, but it does it quick enough. So in Python, what happens is A equals 300. Well, guess what gets evaluated first? The 300. And you know what I'm going to say. Python goes off and creates an object in memory that represents the integer 300. It has a link to the type int. And then it sees the A equal, and that is not, I am not going to use the term assigning a value to a variable. At a high level of abstraction, mathematically, a variable is a good word, and you can use it all the time, just not today, okay? Today you're going to use the words I am using because I want you to start thinking that way. Because then by making you think that way, a whole bunch of other things become much clearer. And then you can go back to using variable later, tomorrow, but you'll have that different understanding slightly of how things are working, and that saves you a lot of pain when you're using Python. So what Python does, it says it sees the A equal, and when it sees name equal, that's a name assignment. That's a name binding operation. It changes the namespace. So it's not changing the 300, it's not changing anything in memory, because the 300 already got created, right? So what it does is it adds the A to the current namespace, and it remembers that A has a pointer or a reference to that object in memory. All right? Assignment operator in Python is a namespace change. It's putting a post-it on the object, and then later I can use that to go look it up. Okay? So let's do that. This is monumentous. We're actually going to change the namespace. That's what happened. Okay, so let's see. let's show what my current names are. And let me back up. The reason I'm using this complicated code, usually I would use dir, dir, open paren, close paren. It gives you dozens and dozens of variables because the Jupyter Notebook has lots and lots of names. So that's why I'm using this underscore vars IDs. All right, so let's see what's in our namespace. Okay, I've got a new name, A, and it's got the value 300, and it's got that ID. So now, when I type the name A, Python says, well, it's not a string literal, it's not an int, it's not a float, it's not a list, it's not a tuple, it's not any of those other things, but it is a valid identifier because it starts with a letter and has nothing but letters and numbers and underscores after it with no spaces. All right? So it goes and looks up this, goes and finds this object, and then throws away the A, in a sense, right? So now Python has this object which represents the integer 300, and it prints the value of it, right? So by the time it goes to print the 300, it doesn't know that it was called A. And in fact, it can't ask. Python can't know what the names of that object are by asking the object. The object does not store its own name, right? So nowhere in here is a reference back to the word A, or the identifier A. So that's another thing that's helpful to understand. All right, see if it works. It did. All right, so let's do it again. Still there, same one. Oh, no, it's not the same one. Look at that. It moved. Well, no, it didn't move. It created it. So what happened is, once I did the A equals 300, so I assigned it here, it saw the A equals 300, it went off and created a new object, 300. That's not guaranteed to happen. It's up to Python what it does. Ints are immutable, they can't be changed. So whether it creates a new one every time or reuses one that exists doesn't change what you're doing with your program. Okay? So we'll sort of think about that to help us understand the layer below, but it doesn't really matter. All right, so let's keep going here. So now we can access A, and it's going to show us 300. Looks like the other 300 did. And again, at the level we're programming in, they are the same. They are equal. All right. So what if I try to access this? All right. Those of you new to programming, and even some of you not, are used to ignoring errors. I know this from helping people who are learning programming at my workplace, and you just ignore the error and try to figure it out some other way. Read the error message, okay? Trust me. After you read the 10th one, they'll start to make sense, and it will benefit you a lot. So the error is a name error. So the capital N, capital E, camel case name error, that's the name of the exception that Python raised. It gives you a traceback, which is very boring when you're working in the REPL, because usually it would tell you this function in this file called this function in that file called this function. Well, here it's just, there's no file. It's just the console, and there's just one line. And then it actually shows you, tells you what happened. Well, the name B is not defined. And it shows you where in the line it failed as well, which, again, you can't even see that there. If it's even there, I think it is. Okay. So what's going to happen when I hit Shift-Enter here? Anybody want to try? You'll get it wrong, because I'm awful in terms of I want to use exactly the right language. Say again, louder, so others can hear. Close, very close. He said a new object 400 will be attached to the name A. I would say an object representing 400 will get created. It might be new, it might exist already. We don't know. That's a Python implementation detail that isn't our problem or business. And the name A is attached to the object 400, not the other way around, is the better way to think about it, right? So the post-it is put onto the object. The letter A, right? Take that post-it note and stick it on here. And then when Python has an index of the post-it notes, so when you say, give me A, it can find it quickly. But the object doesn't know its own name. Great. All right. And it did it. And there we go, 400. And now we can access it. Yeah. Oh, what about this? What is B equal A going to do? Well, it's going to look up the A first and get back an object reference. And then it's going to do a name assignment, B equal, which is a namespace operation. It's going to add a B, all right? And what is it going to put it, where does it put what the B is going to refer to is that object because that's what it got back from the A lookup, right? So here we go. And now B is 400, A is 400. I'm going to use is. You should almost never use is. If you're writing linked lists and you really need to know, have I come around like a circular list and I need to know have I got back to the beginning, then you would need is maybe. Because you might not, they might be duplicates in the list. And so you can't tell if equality if you've gotten back to the same one. You should use is. You'll often see is in a function when there's a default parameter, which is none, and you'll see if parameter 1 is none, then that's okay. Otherwise, don't use is. What you should be using is equal. Okay, equals, because all you care about is, like there were two 300s earlier, right? Do I care that if I say, is that 300 the same as that 300, when you mean to say, are they the same value, you're going to write code that's incorrect, right? But I'm going to use it here because what it does mean is an operator that you give it two object references and it just checks their IDs to see if they're the same, and if they are, it's the same object, right? So in this case, is this going to be true or false? Cool, I got both answers. So A lookup gets a reference to that object. B lookup gets a here's the ambiguous way to I could think of it this way. Well, A refers to an object that represents 400, and B refers to an object that represents 400, but I don't know if they're the same object. However, because I said B equals A, I actually do know, because I got the object reference back and then added a new value. So here I know that B and A are the same object, i.e. they are two names for the same object. Okay? Oh, good. And we can see that if we look at the IDs, right? They are the same address. How about C equals 400? Can anyone tell me that if A is C is going to be true or false? No, that's not my question. Can anyone tell me? No, no one can tell me what the answer is. I can't tell you what the answer is because I don't know what Python's going to do, right? It turned out in this case it allocated a new one, but it might not have, right? So again, Python has freedom to implement how it wants. You have freedom to work within the contract that Python has given you. The contract is int are immutable. So it doesn't matter if it makes multiple ones because it doesn't use a, well, that's enough. Okay, so let's look and see. All right. Okay, and you can see this again. It's just the ID is how I'm getting those. That's what's printing out there. All right, now A is an int, right? And I'm going to put string in a box that was designed for an int? No, that's not right. A is a name. So if I say A equals ABC, not a problem. It goes off and creates a string object down here that represents the string ABC. And it takes, and here, instead of adding a name to the namespace, it overwrites this value in that key value pair. It's kind of like a dictionary, right? And so I'm going to say, please take the post-it off of the other object and put it on this new string object that got created. Okay, so that's not a problem. So the notion that, it's a variable and it can only have one type, well, that's meaningless in Python because it's just a name referring to an object. The object knows its type, right? Okay, and again, most of this you know, but now you know why you know it. Right, and B is still 400. If we look at this thing, we see, okay. All right, del A is a namespace operation. It is not a request to Python to delete an object. Python does delete objects when it can, and when it can is when the reference count goes down to 0, then it can clean it up using garbage collection. But del A, in this context, del space and a name, says please remove A from the namespace. So cross this off, right? And can anyone tell me if the object that A was referring to got deleted? No, none of you can tell me that. That's the right answer, right? Now, we might be able, I'm wrong. Didn't I say A and B are the same? No, hang on. B and C. Right, so before, when A and B were the same, this diagram, which is further up, if I had done a del A then, you could have told me, no, this didn't get deleted because there's still a name that's bound to it. But then I put the A equals ABC. Thank you. Okay. All right, so what's del A gonna, oh, wait, I did that. Where am I? Del B, let's get rid of that name. And let's get rid of the C name. So it probably cleaned up those things, but can't be guaranteed. All right, so here's how you're supposed to do it. Right, let's say use equality, use double equal to check equality. So let's, let me just demonstrate something here. I equals 10, j equals 10, I equals j. We know that's true. Is I the same object as j? We don't know. Turns out it is in this case. And I can sort of do both of those at the same time. If you put a comma between two expressions in the REPL or in Python, it creates a tuple without the parentheses, and then it returns. And in creating that tuple, it's a tuple with the value of each expression, and then it prints it, so you see it printed as a tuple. And you can see that those are at the same address. What if I do I equals j equals 500? So this is not C where j equals 500 is an assignment expression. It's not that. Meaning assignment statements in Python do not have a value. So if you say a equals 3, that expression doesn't have a value that you can then do something else with. But you are allowed the convenience of saying I equals j equals 500 if you want to give two names to the same object up front. So we'll do that. Give two names to the same object up front. And you can see that they have the same value, of course, and they are the same object because I just gave two names to the same object. Right? And so we're seeing similar to this, the A, B point to the same one. We've got those there. Same there. What if I do an I equal 500, j equal 500? There, they're different. Right? So in case you're curious why that is, you can watch videos of my Epiphanies course, which is more advanced, where basically Python pre-allocates certain integers close to 0 for efficiency. That's why sometimes it recreates them, because there's lots of zeros and ones and fives floating around in the runtime. Let's save a little memory. Okay. All right. So if I type this, is it going to work or not? You can't really tell, right? Well, I know that abs worked and callable worked and true worked. So there are some names that I haven't shown you that are sort of built-in, that are built-in names that aren't visible when you look with vars or with dir as a call, dir open close paren. I keep saying that. What I mean is this, right? If you do that, it shows you the current names, the names in the current namespace, and there's lots of them. That's why I don't use that. So if you do a dir, you won't see abs, but abs is available. So there's the names you create, there's the built-ins that are sort of hiding in the background. And then there's the ones that don't, they're in the standard library, is another one. So math is a standard library module in Python. So if I access it, I get exactly the same error as I did back up when I tried to access the name B before I had added it to the namespace. Right? So math is not defined. I can define it as in tell Python to go get the library and import it and put the math name in the current namespace by doing an import, which we'll talk about a little later. Right? So, and again, it's got that little angle brackets around it. I can look at the attributes of the math module, and there are some under attributes that are sort of implementation-y things, and then a whole bunch of functions and some constants, one of which is math.nan, not a number. And its type is a float. So just as another example of don't trust is, math.nan is math.nan. That's going to be true because it has to be true because this is I'm asking Python, do these two names refer to the same object? Well, they're the same name, they have to refer to the same object, right? They're the same complete name, right? Like math.nan and spam.nan might not be the same object, but math.nan and math.nan are. So it's going to be true is the second value, but the first value is math.nan equal to itself. And the answer is no. And I'm not going to tell you why that's for another tutorial. That has to do with, there are good reasons why that thing exists. It's not a number. It represents not a number. And it's useful in scientific programming, other kinds of stuff. Okay, so that's the end of the lecture, the first part. Now what I'm going to do is let you do the exercises. Remember, when you look at this, don't just hit Shift-Enter. Think about what it's going to do. Try to predict what it's going to do. Write it down if you want to, whatever. And then hit Shift-Enter and see what it actually does. And ideally, it'll always do exactly what you think. I'm pretty sure I've put enough weird things in here that you're not going to be able to do that you'll be surprised sometimes. There are approximately 50 to 100 errors in this intentionally. So you will see error messages. It's because I want you to see the error message. I'd like you to maybe think that, so sometimes you'll figure out ahead of time, oh, this might not work. Sometimes you won't, and then I want you to think about, why did this raise an error message? And then we'll talk about it as a group, as in I will go through it. So you don't need to, don't worry about understanding all of it. Okay, question? Sort of. It's a function that I wrote and I put in the notebook. And I put it in the notebook with a write file, which means if you execute this cell, it will write it. And then I loaded it back in because I wanted to actually evaluate it. And then I clicked back in that cell and hit Shift-Enter to evaluate it after I loaded it. So it's kind of my hack so that you can get it too without me shipping all those files. Although I did in the zip, you have it there as well, the vars ID. So load vars ID, that %load is, which once it does it, it comments it out, is the magic that puts it in that namespace, in the current namespace. And I didn't just do an import because it actually has to do some weird stuff with the names to try to, yeah. If anyone has a better way to do it, I'd love to hear it. Okay, so your turn to do exercises. And yeah, so there's not too many, so I'll give you about, this one I'll give you lots of time. I'll give you a good 5 minutes. And I'll wander around and ask you questions, and then we'll go through it together. There's the link. bit.ly/PyCon 2019-immersion. finish the exercises? Cool. All right, they will get harder, trust me. All right, so any surprises here? Oh, there's a surprise. What was that? M equals N equals 1 through 3. So that's how you, oh no, that's not a surprise. We learned both of those things. That's not new. Say again? So, no surprises here. Now that my mic is on, I'll just repeat that. These are all fairly straightforward. You've seen the pieces of this, and we just put them together there. M is N. It is, because I said M equals N equals N. M equals N equals whatever. So I told Python I want two names for the same object. So this one, I said earlier, if you have name equal and something, it's a namespace operation. This is not name equal something. This is name square bracket something square bracket equal. So this instead is a request to the object that M is bound to. And the request is to change its element at index 1. Python starts counting at 0 to be something else. And so you can see it changed it. And of course, because N and M are bound to the same one, it changed. Not they both changed. There's only one, and it changed. Okay? Okay. Well, let's go a little faster and just explore numbers for time. So numbers. There's another error, syntax error. It shows you exactly where with the little hat there, right? So it's showing you it's just after or at. It got done reading the minus and didn't know what to do with that. Obviously something like 1 minus 2 would work, but 1 minus by itself isn't going to work. 1 equals 2, syntax error. Can't assign to a literal. Good. That would be strange. True and false values coming from equal and not equal. Less than or equal to. Multiplication works, addition works, division works, or you can use floor division, which always returns an integer, and that's what Python 2's slash did. That was one of the big changes between Python 2 and Python 3. Clock or modulo division, right? Like if it's 9 o'clock, what's in 14 hours from now? It'll be 11 o'clock, right? Because 14, it's 2 hours after 9 in a sense. That's why we call it clock division. So all of these are available to you. It's remainder is what it is. This is the remainder. 9 divides 3 cleanly with nothing left over. Here's the int we saw earlier. We know it's callable. Let's try calling it a few times. So we call it, pass it a 2. It just gives us back a 2. Maybe the same one, maybe a different one. If we give it a float, does it round it or truncate it? It truncates it. If I give it a string, it will convert it from a string. It'll turn that string, it'll take the string and derive an integer from it. If I give it a float that looks like a string, it says, no, that sounds like a bug to me. Tell me exactly what you want if you really want to do that. Right? So here we got value error now. So value error is anytime there's something wrong with a value. And this is one that you might commonly use. If you're writing code and someone gives you a value that's not good, just raise a value error and give it a different argument. Right? So you're reading the error message, right? Because I told you got to read the error message. Anything interesting about this error message? Yeah, what's that about base 10? Invalid literal for int with base 10. Why is it telling us about base 10? Well, it's because there are other bases. So that's a clue, actually. And it cannot read your mind. So int 4 is obviously going to fail with the same error. Float. So float we can use on 2.9, and it knows what to do, and it allows it. This is going to do what? Raise an exception. So it throws or raises an exception, and that's the zero division error. So there's a new one. Can we add types that are different? Yeah, it'll coerce. So it creates a new one. So I just used the word coerce, and I didn't want to do that. Because coerce usually, in statically compiled languages, coerce usually means, I told you, compiler, that that I represents an integer, but I want you to actually start treating the contents of that box as a float instead, or something like that. That's what coerce usually means. That's what coerce often means in static languages, statically typed compiled languages. So here what it's doing is just saying, well, yeah, basically what this really is going on here is the integer object, if you pass it, if you call its add method, it's dunder add method, and you pass it an object which is a float, the integer object knows how to add those two together. And it says, oh, I can do that, and I'll return a float. Okay, and I don't need to do that because I already, oh yeah, I do because it's a new notebook. The reason I put this in every notebook is because you have to reload it. And those of you who are not using Jupyter Notebook, just use dir instead, is my suggestion. Right. Okay. A plus 1. That should just give me a new 2. It does. But why didn't it change it? Well, because I didn't change it, right? By the time Python had the 2, it didn't even know that I'd named it A or used the name A earlier. If I do B equals A plus 1, though, well, that's going to do a regular assignment. So it's adding a new name to the namespace based on the value 2. And we got the 2, and we got the 1. Okay. A, yeah. A plus equal 1. That's valid Python. And what it looks like it does is the same thing as A equals A plus 1. And that's sometimes true, but not always. So plus equal is actually, and again, if you don't remember this is fine. Plus equal is actually an operator in Python that calls not the dunder add method, it calls the dunder I add method. And dunder I add is supposed to try to change itself. But if it can't, like an int, which is immutable, then it just falls back on turning it into A equals A plus 1. So that's kind of some interesting stuff. And I think we see some of that later, if I remember correctly. A++, sorry, not allowed. Some of you won't like that. All right, okay. Abs, yeah. What's this one going to do? What? It's going to fail. How is it going to fail? What exception is it going to raise? A name error, right. So it's going to say, I don't know about that name. Name error, name sign is not defined. So I import math, because again, I imported it earlier, but that was the earlier notebook. I've switched notebooks, so I've lost all that history. So I import math, and I can see the math modules in there. And so now what's sign pi over 2 going to do? It's going to fail because look at the names in my namespace. I got A and I got B and I got math, but I don't have sign and I don't have pi, right? So that's different than some languages. Some languages you import the module, all the names come in. Python, just the module name comes in unless you do something different, okay? So let's see. Oh, I was right. So, but math is there, right? Math is there and there's the module and I can look at what's in the math module. There are the attributes of it, which include sign and pi and et cetera. So I can do this. Math.sign, math.pi. And this is actually the recommended way to do it, right? And the reason for that is when, like for a short module name, math.sign, well, again, usually the recommended way to do it. So you could just import the names you want from modules. It's recommended, good style, is to just import the name of the module, and then it's clear to the reader of the code who's never seen the code before, oh, you mean the sign in the math module, as opposed to the sign in the NumPy module, right? Like, because the names do show up other places. There are exceptions where it's a really long module name, you can shorten it, but usually spell them out. It takes a little more time to type, but you're going to read your code a lot more than you're going to write it, and other people are going to read your code after it's written. All right, get off that soapbox. There we go. But you can do a from math import sign to pi. And obviously, if you're just writing code, oh, I need this script, I'll throw it away after this afternoon. Do whatever you want. So you can do that. You can even do from math import star, and it'll just bring them all in. So good when you're exploring, but not when you're writing code that's going to be around for a while. Okay, so then sign pi over 2 works. What do you think this is going to do? Can you tell me what this is going to do? Referring to the same object. Yeah. So do these two names refer to the same object? Can you reliably answer that question? You actually can, unless something weird has gone on with the imports. Normally when Python imports a module, it only imports it once. And so when I do, even though I imported math, and then I did from math import sign, it didn't go reload a new module object and then go grab something from inside it. It reused all that. So there are some weird edge cases with, like the way PyTest works, for example, where if you've done things wrong, you might get two, but that's a bigger problem. So yeah, this is reliably going to be true. That in this, what we've done so far, it's the same. So those are just two names for the same object. Okay. You can use help is a built-in function, by the way, that lets you just look at stuff right in the, and in the Jupyter, in IPython, which is what Jupyter is running, you can also do it this way or this way. And depending on, like Jupyter brings up this little window down below, which you can then hit escape to close. You can do other things too, by the way. Like you can hit tab and it'll bring up completions for you. There are a few things that Jupyter Notebook does. Okay, so that was a little faster. We'll go faster yet. You like drinking from a fire hose soon. So go play for a little bit, see what these do. Give you about half a minute. Told you I wasn't going to let you finish most of them. Okay, so I'm going to go through these. The ones you didn't finish, again, you can see what I'm doing. You can do them yourself later. And again, don't memorize all this stuff. This is just, let it wash over you and you'll absorb it. And you'll remember parts of it later. And you'll get a sense for how Python works. And that will give you more value than memorizing lots of little things. Okay, so yeah, integers. All these are fairly straightforward. Order of precedence, well, you can look it up or you can add parentheses to make it more clear for your reader who might also not remember them exactly. You can do, this one's kind of nice, you can actually check the less than and have 3 values or more. It just, instead of putting in the ands. Exponentiation, what if we go over our 64-bit architecture? Python doesn't care, it slows down, but it works. Rounds, makes sense. Let's create a third. And if we round it, no surprises there. Now this looks like an error, doesn't it? Round with a -1. There are a lot of cases in Python where there's sort of edge cases that it's like, oh yeah, we can't use that. Oh, but there's something neat we could do that with that would be really useful. Like, let's move the decimal plates the other direction. Okay, so look for those, and you'll see there's lots of little things. I keep running into them occasionally. And then our advanced exercises. Well, that's exciting. Type int, callable int, help callable. What else? Int. If you call int with no arguments, it gives you back a 0, and of course it's equal to 0. Type of int is type. Type of 1 is int. Type of int is type. Interesting. So what I'm calling as a function is actually a class or a type, or again the lines between a class and an object. If it's callable, that's what matters, and I can call it. It acts like a function. Okay. And of course, type of 0 is int, because int. Okay. Int 43. What else? We did this before. You saw it already. Int z, same thing. But if I pass a second argument, right? So this is an optional argument. Python has optional arguments that you can put in sometimes. You don't have to. And here's an example of, and so they add lots of richness and power to the functions you're calling. Is that, int converts from ints. Oh, but it also converts from ints using different base cases, for example. Okay, let's move on to strings. That's a string of 4 characters. That's a string of 1 character. There is no character type in Python. There are only strings. And they have 0, 1, or more characters. Okay? Length of that is 4, length of that is 1. The types of these are the same because they're both type str. You can use single quotes or double quotes, which is convenient, because if you want to put a quote in the middle, it ain't going to work, right? I've got a quote and then a quote, so that's a string, and then Python sees the rest and says, I don't know what to do with that. So I could escape it with a backslash to say, don't escape. The backslash says, don't treat the following character the way you usually would. So in this case, it means don't treat it like the end of the string, just put it in the string. Right? So that works, and you notice it comes back and puts quotes with a single quote in the middle, double quotes on the outside, and that's sort of a clue that, right, if you want to put a single quote in a string, use double quotes. If you want to put a double quote in a string, use the single quotes. That's convenient. Here's another example. What if I want to have a string that goes over multiple lines? Well, it can't work unless you put triple quotes. So Python lets you put triple quotes, and then it does work. And you notice that the new line got inserted here as the escaped end, which means put a new line character in here, not a backslash and an end. So put in a single character, right? There are cases that won't quite work. Like here, I've got 4 quotes in a row. Yeah, it doesn't know what to do. So I use triple single quotes instead. You don't need to have the triple quotes. You can actually put the backslash n directly like that. In is an operator in Python that says, is something in something else? Well, in this case, it means for strings, is this string in the other string? Is it a substring of that string? And the answer there is yes. And if you put a not in front of any expression, it will reverse it. You can also use not in. 2 words, 1 operator, which just makes it read easier. So that's kind of convenient. Square bracket 0, we saw it earlier when we assigned m sub 1 equal quote b. Here we're going to access, right? So we're going to say, give me the first element of that iterable or that sequence. Not iterable, sorry, that sequence, right? So sequence types, tuple, dict, string, list, and other ones that people have written. So this says, get me out that element, and it gives you back. In this case, you ask a string for its first character, you get back a string of 1 character. Okay? I think this is the last time I'm going to use this thing, the vars ID, but let's put it in there. All right, so s equals t equals hello, right? And these, we can look at both its values. Yes?
Sorry, why do you have to run it twice?
Why what?
For the vars ID.
Why do I have to do what?
Do it twice.
Oh, so the load loads it into the cell, and then I have to go back in the cell and hit Shift Enter to evaluate the cell. And it's a hack to make, again, it's not normal, but it works because I want to do stuff with the reason that I have to do it that way is because of this stuff here with the global. That's what the star, percent load. Percent load loads the contents of a file into a cell. It does not execute it. Okay, so there's the S and the T, which are two names for the same object, kind of like that, right? So if we do this, S is now a name that is bound to or refers to a string jello, because plus does concatenation. And what about T? Yeah, so S equal, this is a namespace operation. So I changed S, I didn't change T, right? So T is still going to be hello. How about if I do it this way? Strings are immutable. It's not going to let me do this. Does not support item assignment, right? I can access the J that I put in this string, but I can't change it. And you can see that S is still, of course, jello. Okay, how about this? M equals N equals 1, 2, 3. Right? So there we could change what was in there. Lists are mutable, strings are not. So this didn't give me an error. All right, how about B1 equals B quote. So there are a number of things you can put right in front of the quote, a string literal. A string literal is the beginning quote, end quote, and the characters inside. A B in front changes it slightly. There's a B for bytes, there's an R for raw, there's U for Unicode, which isn't needed in Python 3 because they're all Unicode. And I think, F, which we'll see later. So B is the way we ask Python to give me a binary representation of something. And when I do that, what's B made of? The answer is it's made of numbers, right? And it's a sequence of numbers, and I can iterate over it. Oh, bytes is another one I forgot to mention. I can iterate over it, so if I pass it to list will take whatever you give it and try to iterate over it, and it will then create a list of those values. So when I look at it that way, you can see that hello. So it's convenience that lets through. I'm harping on this because character encoding is really difficult to get right, and it's really hard to think about, partly because it's so ingrained in our way of, it's abstracted away so well by our tools that it's hard to see what's really going on. Debugging, at least twice a year, I'm helping some team debug, diagnose a character encoding problem, and they're always confused. And so then I start explaining it to them, and I start getting confused because it's just a really confusing thing. So my hint to you here, which I'll credit to Doug McNeil, who showed me this, pointed out the fact that Python lets you type a string to create a bytes is a little bit misleading. Worse than that, maybe, is the fact that it shows it to you as what looks a lot like a string. It's not a string. It's just a bunch of numbers that, for convenience sake, it will show you what they represent in ASCII. Okay? If you remember that, it'll help a little bit in terms of not getting confused about Unicode. Character encoding generally. All right, so is 2 equal to 2.0? I could probably do a poll and figure out who the real mathematicians are in the room. Right? Sure it is. 2.0 is a floating point representation of the number 2. Exactly 2. You could write your own language and do it differently, but this is what Python decided. I actually don't know. I think that's probably generally true in languages, isn't it? I don't know. Anyway, B1 and S1, are they the same? Absolutely not. Why? Because if they made this the same, like in Python 2, it makes you write bugs more easily. So Python 2 had lots of good support for character encoding and Unicode. Python 3 just tightened up some areas to make you think about it and force you not to just do it without intentionally thinking what you're doing. If I decode it, so bytes, I can decode it, and then it will turn it into a string, right? So a string in Python is a high level, an abstraction representing characters. It may be stored as numbers. I'm sure it's stored as numbers. Everything is in a computer, but it's representing characters. When you get a file from someone else, they should tell you what the encoding is. You can read it. Decoding it into characters. And then when you're ready to do something with it, like send it to someone else or send it over the wireshed, then you can encode it in a particular encoding. And you should always say which one. As recently as last year, I think I told people in an audience like this that the default encoding for Python is UTF-8. I was wrong. It's actually, see, it's easy to get wrong. It's actually dependent on the platform. So if you write code on one platform and you're encoding files, as in writing a string to disk, and you don't specify the encoding, and you move it to another operating system and run the same code, it may produce a different result. You have to think about these things. All right, I'll get off my soapbox. You got a question?
No, I was looking back in your 2 equals 2.
Yeah.
That you used equal equals in that case.
Yes, this is comparison, equal, equal. And some other people may have missed that too. Thank you. So I used equal, equal, that's why it's true. If I'd done is, absolutely would be false. Okay, so what does decode do? Well, it does stuff, and it's interesting. And you can look at it later. I have an advanced exercise at the end of this, in one of the later notebooks, which we almost certainly won't get to, which lets you play around with encoding. I encourage you to do that, to understand it better. Okay, your turn to do some stuff with strings for a few minutes. Who thinks I'm going too fast? Too slow? Okay. Okay, I'm going to move us along. Let's turn the mic on. Okay, I'm going to move us along. I'll go through these and then break in about 5 minutes. So this is exploring the raw string, the R you put in front of it. So if you put an R in front of a string that has an escaped character in it, it changes what happens, right? So it says the raw string says a slash is just a slash. Don't use it to escape characters. Useful in regular expressions, some other cases. And you can see these, you can sort of figure out that, oh yeah, those are different. The \n is that 1 or 2 characters. Well, it depends on whether you've used, how you've done it. Write an expression of value. I'm going to skip that because we're close to the break. You can do math with strings, which means multiple concatenations. You can't concatenate ints and strings. Oh, new error, type error, unsupported operand types for plus, int and str. Okay, not much interesting there. Later on, we'll see the same type error and the same error message, and it will give you some clues about something you can do. I can add strings together, though. Interestingly, I can even add them together without an add. So in source code in Python, if there are 2 string literals next to each other, it will combine them, and that's convenience for certain cases, especially if you're trying to have a single string go across lots of lines, for example. Okay, we'll do a little bit more with encoding here. Here's a \u, says give me code point 24 from Unicode, and turn that into the abstraction of code point 24. And this one says, don't give me code point 24, give me the Unicode character that is named $. And they're all the same. Okay, so just, again, the advanced exercises that you'll do on your own at the end are interesting. Okay, so strings have functions and methods, lots of them. Again, this will just be a blur. Don't remember them, just remember that, oh yeah, you can do stuff like that with strings. and that'll be helpful. Length is a function that takes any iterable and figures out how long it is, or asks it how long it is, depending on whether or not it's supplied the dunderlen function. It depends on how it implements that. But regardless, it'll, I think I might be wrong on that. No, I think I'm right, that it will take any iterable and consume it, but I'm not sure now. Okay, min is a function that same thing, max, right? So what it did, it takes spam, iterates over it into the separate characters as strings, and then returns the one that's the smallest. Sorted, right? Always returns a list of whatever you iterate over. Does it start with S? Yep. Does it start with SP? Does it end with M? Give me an uppercase version of that. Give me a lowercase version of that. Strip spaces from the front and the back. Strip spaces only from the right side. Spaces, white space. Sorry, not spaces. Tab, probably vertical tab, maybe form feed, but basically tab space are the ones you'll, and new line, of course. Or only from the left side, right? This is misleading. Doesn't that look a lot like it's the right way to remove the extension from a file name? Well, it's not. The strip functions take a string and interpret that string as a set of characters that it should remove. So it will remove any of those characters until it gets, from the right side in this case, until it gets to a character that's not in that set, and then it stops. And this is easy bug to write, and there's good proof of it, right? It's going to just keep going until it gets to the dot. As long as it's in, no, sorry, until it consumes the last dot. Because it says, any dots, C's, S's, or V's, just chew them all up. And when you run out of those, then stop. And so it stops just before the E. Stops. Yeah, there's OS path, has a bunch of functions, and there's a newer pathlib module. If you're doing file names, so if what you want to do is work with file names and remove extensions, use pathlib. Or the older OS path. Pathlib's nicer in many ways. A split is a method called on a string which returns a list of strings split on whitespace by default. Not just one, but could be multiple white spaces. Or if you give it a specific string, it will split on that specific string. So if you give it a space character, it won't split on tabs or new lines. New lines it might not, I can't remember. So here it will actually split on that exact one, and it throws away the other piece, right? So it throws away the space dash space and just gives a list of 3 strings. Type of spam. Here all the function, let me just, lots of functions there. Let me just print them on one page there. So all the dunder functions you could ignore for now, and then here are all the other ones, case, capitalize, case fold, center, count, encode, lots and lots of stuff. Anything you might think you would want to do with the string, it's probably already in there. And if not, Stack Overflow. All right. Yeah, that doesn't matter. Okay, you can look for the offset. Find in spam PA, and you find it at character offset 1. If you look for something that's not in there, it raises a value error. Find is just like index, except instead of raising a value error, it returns -1. Choose the one you want. Break time, I'm almost done. Find, right, so we can find those things. You can replace all the E's with 3's or just one of them, optional. Optional argument there, say just first one. All right, so I will stop there. You can do exercises now and then go for break or vice versa. We will come back from break in, break is 20 minutes, so I'll give you 25 or 22, whatever. So you have time to do the exercises before or after, whichever you prefer. over? Can't remember. 10:15 to 10:35? What's that? I can't remember. What is it? It's 20 minutes. 10:15, so 10:35, so we're done. All right, I'll turn my microphone on soon. Okay, welcome back from the break. I will go through these exercises. All right, so we saw sorted before. Reverse equals true, an optional argument. If we do reversed, it gives us back a reversed object, which is kind of interesting. Basically, it's lazy evaluation, so it will iterate over that later when you actually try to iterate over it, if needed. And you can force that. Easy way you can iterate over an iterator is just pass it off to list. List tries to iterate over whatever you hand to it, and then it will return a list of whatever it iterated over, of those elements. Upper is upper. There's a whole bunch of these. Title is title. Right? And remember, these are returning new strings, right? So, which reminds me, one of the questions someone asked is, how did this work? How did, like, it change the string? And it didn't change the string. It gave us back a new string, which was a copy of the old string changed, right? So Python is allowed to change strings. Like it basically copied the string and created a new string. And it did that in code written in C, so it's pretty fast. Going back down here, though. So here's title. And here's an example where we take, where we do what's called method chaining. So in method chaining, what happens is, so the method is called on the object, and it returns a new string. That string object, that then you can imagine replacing this, the swap case method is called on that new string, and it returns yet another new string. Right, so you get that with the title case reversed kind of. Here's the in you saw earlier. So the optional argument to find says start looking at a particular offset. All right, so what is s.index0, s.index space? Anyone figure that out? Looks for what? That's right. It looks for the, I would say it looks for the first O after the first space. Yep. Okay. And there you can see how that worked. So how about an expression to check for more spaces than non-spaces in a string? Well, this is going to be part of it, right? How many spaces are there in the string? Is that more than, what's that? So I heard some people took the length of the string and divided it by 2. That's an option. What's that? Yeah, okay, so what you said. So you have to, yeah, so that's one way is to do something like that. I may have the point is that's the gist of it. You can figure out the details. Another is something like that. Again, I'm not saying that's the right answer, but that's the way to figure out how many are non-spaces in a string. Well, you could take the length, what would be the length of it, wouldn't it be? You can take the length of it if you got rid of the spaces. Right? And again, I may need an extra half or something like that. I'm not worrying about the details. I'll let you worry about that. Okay? Any questions before we go on? All right. String formatting. Well, you remember what 3 does. if you put a 3 on a line by itself in a Python script or program and you run it, you will not see the value 3 printed to standard output. You would need to use the print function, okay? The reason we're seeing it here is because it's the read eval print loop. It's the P in REPL, right? So print is an easy way to get stuff out to standard output. You can print multiple objects. It puts spaces between them. Not between the objects, but between their string representations that it prints, right? And if you print, might be hard to see there, but if we print, there you can see if you put new lines, it prints multiple lines in there like that. There, you can use this. Those of you who were sad that ++ didn't work, well, at least you got this. This was the print formatting, or the string formatting operator in Python until, I can't remember when they added .format, 2.6 or 2.7. And most people, I think, I certainly, anyway, find the .format method on string more powerful than the percent operator, this percent operator, which obviously, which we saw earlier as modulo. It's also, it's here, it's used to say interpolate, basically take that 3 and stick it in where the percent %d is. Question?
Just a few cells up, when you did prints into the 3 and 4, if there's a space, it gets inserted between those. But
Yep.
earlier, when you added 2 strings together, there's no space automatically added. So is that a function of print, or is that because you're adding a instance with the string?
No, so if there are 2 string, the question is why is it different with string literals? If Python sees 2 string literals, and these are the quote marks, with only white space between them, or even a new line, that's still a valid expression like in parentheses, it will just create 1 string literal. It'll create 1 string object from the 2 of them. So that's part of the syntax of reading the Python code. Print takes whatever objects you give to it and asks them for their string representations and then prints them out with a space between each of those. Okay, so .format, basically it looks for curly braces in the string, and the technical term is interpolates, or inserts the value of 3 as a string into that location. You get 3 good reasons. You can pass it arguments that aren't used, and that's okay. And occasionally that's handy. So here's, and you can have a string that doesn't have any arguments and doesn't have any curly braces. It just says, okay, I'll give you the string back. So there's another example of an argument that's not used. Here's an example of an argument that's missing, and we get an index error, tuple index out of range. Kind of an odd error, but it's because of how it's implemented. Right, so it couldn't find, it said, oh, okay, I'm supposed to substitute something, but I can't find anything. So here, hello class. So here you can do multiple ones and it counts. So the H goes in the first place, etc. You can use numbers if you want, which is handy if you, here's a bad case of using it. That's just confusing. But this one is actually useful, right? Because I wanted to repeat one of them. I didn't want to put it in over here a second time. So it does 0 gets to high, and the 0 here also goes to high, whereas the 1 goes to class. Lots of stuff here. You can format. So if you see a :d, so curly brace, and then maybe a 0, or a name we'll see later, and then you have colon, and then some format specifiers. And there's a whole mini language, format specification language, but it lets you do tons of stuff. Like you can, D is, show me this number, align this decimal, aligned left, right, centered, put a plus in front of it, otherwise it's only for negative. I'm not going to explain all these things. So here are the default left, right, and center. So you can look at these later, or go look at the format mini language spec. This one's centered, I think, and uses a different character. How many decimals after the decimal point? Truncate a string, like say, show me the string S. S means string, but limit it to 8 characters. More interestingly, you can put in names, right? So you can say greet who and have placeholders that are easier to read, like that. Hang on, let me just remind myself. I converted this from a different format recently. The edit, I'll remind me later to clean that up a little bit better. Which reminds me, part of why this is as good as it is, which hopefully is good for you, is because other people have given me feedback in the past, saying, oh, maybe you could do that differently. So at the end, in the survey, if you have comments saying, this part was more confusing than that part, anything you can do to give me feedback, I can improve this for future uses. And you can thank all the people that gave me feedback in the past for what you're seeing, because I've learned lots of stuff teaching this class, especially when people point out mistakes. That's that great thing about learning, is it really makes you think hard about what you're teaching. Anyway, so you can also do this. So here I'm going to have a method, an M. I'm going to have M bound to this list of those two strings. And then in here, I'm going to say 0 and 0. So I'm accessing the 0th, in both cases, the 0th argument, which is M, that list. And I'm going to use square bracket 0 and square bracket 1. Right? And so I get the hi in the class put in there. You can also use dot. So here is one way. This doesn't use dot. It just says P is true's under doc attribute. Or I could just pass P equals true and then use P dot under doc here. Right? So you can do some of the syntax inside the string. Python 3.6 added F strings, which are really nice, make the code much easier to read. And what they do is when the F string literal is, when it's compiled, it saves this string, and then when it's executed, when it actually runs the F string, when it's actually used in this code, I might be not quite saying that precisely enough. Then it looks in the local namespace. It looks in the current namespace to find the names. So greet, it'll go look outside of this statement into, are there any names that I can use to do that substitution? So that's very nice. F strings don't just do name substitutions, though. They do lots of expressions, right? So we could do that, or we could do that. So here I'm showing you the difference. This is a regular string, not an F string, and it just prints that out. This is a regular string with curly braces, and it just puts in the curly braces. This is an F string, and it has curly braces, and because it's an F string, it looks at the curly braces and does something, which is it evaluates this, and basically it does the code work of going to find abs and calling it and getting back the 3, and it puts the 3 in. Okay, so you see the difference here? Not an F string, not an F string is an F string. Okay? Hang on, make a note. I didn't like that delivery as well as, that changed that, and I'm not totally happy with how it went. Here's another example, right? So here the dot upper is inside, so here's the F string that starts with the quote and ends with the quote. Inside the curly braces, I have a string dot upper. So this expression gets evaluated, right? Again, that's kind of confusing. I'm not sure I would write code like that because it's got the quotes and the F string and everything else, like a quote inside there. Here's an example of one with a new line. And F string expression part cannot include a backslash, right? So there are some limitations. You can't put arbitrary code inside an F string, but you can do some pretty crazy things. So don't. Doing crazy things is not good. It's easy to be too clever with Python. Make the code easy to read for future readers. Your turn to do some exercises. okay, I'm going to go ahead and go through these quickly. There's not a lot of new stuff here. Well, lots of little details, but the core, there's no big new ideas, I don't think. So I can change, by default, print adds a new line at the end of what it prints, but I can change that to print something else, like a space and a less than and a dash dash and a new line. Suppose I don't want to print a new line at all. You would think that saying end equals none would do that, but it doesn't. And the reason is end equals none is how it was written. When the function was written, the print function, if you don't pass an optional argument, Python passes none, right? So this is a gotcha you need to watch out for. So in a case like that, where you actually want something that's kind of like none, well, what I want is an empty string. What string should I put at the end? This is the way you get that, right? Is end it with an empty string as opposed to ending it with the default is sort of the way you can read the difference between these two. Okay, so that's a little bit tricky. Nothing surprising here. Nothing too surprising here. Right, it's just doing various values. Colon B is how you do stuff in binary if you want to do some binary math, or colon X for hex or O for octal. Percent will do both the math for you to make it 33 point instead of 0.33 and add the percent. And you can say, and here's how much of it I want, right? And it puts the percent character on as well. This one's kind of cool. So sometimes you don't know, maybe this digit's here. Like here, I know I want 5.2. I want 5 wide and 2 decimal points. But maybe you don't know until it's some configuration file or someone entered it in your application as part of the run. Or it changes depending on the type. So you can put the curly braces here, and it interpolates that as well, right? And the dot format method can be implemented on other types. There aren't very many that have. Datetime is one of them. Here's some other examples where we're doing the dot, and again, a more complicated expression. Okay. Oh, I didn't get ahead on this. Okay. So moving on to tuples and lists. Sorry. Any questions? All right. Lists. Nothing new here. The list is 1, 2, 3. So what's m sub 3 going to give us? Index error. List out of range. Okay. Length of m, 3. Oh, okay. So what if I want the last element? Well, I need to do some math. Or, thank goodness, there's the -1 option in Python that says, give me the last one. So minus means start counting from the end. -1 is the last character. -2, -3, so I'm getting the 3, the 2, the 1. If I try -4, I'll get an index error. Tuple, very similar. You can pass the tuple to a list. I'll give you that list. Let's see, what else here? This should all look familiar, right? Just sort of refreshing those little gray cells. I can take a list and pass it to a tuple, and it'll create such a thing. So a tuple is immutable. Doesn't mean it's homogeneous, right? Or homogeneous. You can still have mixed data types in a tuple, and that's very common. So let's look at that tuple. Oops, sorry. There it is. And tuples are immutable, therefore this will fail. Tuple object does not support item assignment. We saw that same message with string, I think it was. So if I want to create one like that, I could though. And then I can see it. Oh, so if m is the list 1, b, and 3, and I do m plus 4, adding lists together does that. It creates a new list from the two lists that got added together, right? And if I look at M, what does M bound to? Is it going to be 1B34 or 1B3? Yeah, I didn't change it. All right, how about a tuple? Let's say tuple, and if I add 4 to that, what's this going to do? Read the error message. Can only concatenate tuple, not int, to tuple. So it's giving me a hint. Always read the error messages. Get in that habit, right? So let's try doing that. Because earlier I did m plus square bracket 4. Here I just did t plus 4. Here I'm going to do t plus round bracket 4, because tuples always show up as round brackets. And I still get the not int. So can only concatenate tuple, not int, to tuple. So in other words, this got evaluated as an int. Parentheses are used for tuples. They're also used for math. So in Python, and mathy things, like grouping things together. So Python saw the parentheses around the 4 and threw them away, right? What does this do? That worked, right? So I can create an empty tuple like that, but this doesn't work for an empty tuple. And obviously, adding more parentheses won't help. Well, I actually don't know that. Adding up to 3 more parentheses won't help. I haven't tried more. I can do this. No. Int object is not iterable. So I have to pass tuple an object which is iterable. Okay. Let's try passing an object that is iterable. That works. So here's the answer, is if you need a tuple of one item, you need a comma, or something other way, right? So that's the sort of this weird edge between 2 different uses of parentheses in a language. So now that we have that, okay, that's good. Now I can do that, and I get back 1B34. And T will now have 1B3, right? Because we can't change the tuple. Can I do math like I did with strings, as in multiply? Can I use the star to do something? Yes. Right? And that's actually quite handy. Hang on. For example, what's easier to read? That? Oops, sorry. Or this? Right? So that's the rare case when I've actually used star with strings, is I need a certain number of spaces. There are other ways to do it too. But anyway, call tuple, like all the data types, you call it with no arguments, and it returns sort of the empty version of it. And the type of that is tuple. Okay, let's do some stuff with lists. There's the B, C, D, F. It's got a length, it's got a min, it's got a max. I can call sorted. I can call reversed, same as before with string. Or I can pass it off to list to actually instantiate or to actually do the iteration and pull them out and then turn them into put them in a list. M is B, C, D, F. Insert 0, comma A says, please insert an A into this list at element 0. Okay? Lists are mutable. You can change them, so you can do that. So what's m.insert -1 going to do? Remember what -1 does? It refers to the last element. So if I want to insert before the last element is what this means, as opposed to insert at the end of the list. All right, so there's that. Look at all those E's. Okay, 3 E's there. So if I do remove E, it removed 1 or 3. Well, if it removed 3, then when I do this, it'll give me an error. So I think it just removed 1. So every time, so remove doesn't ask, it's looking for, remove doesn't say remove from the, it's not an integer offset into the list. It's saying just remove the element that matches that, that's equal to that. Okay? Pop, again, just to remind you, this is just, here's an overview of all the things you can do with lists. Very, very handy. Pop takes, removes the last element and returns it, as opposed to these others. Remove returns nothing. Insert returns nothing. None, specifically. Right? Okay. Tuples, you can do assignments, name binding, namespace operation with tuples, right? So that's a way to assign I1 and J2. Oh, I can't believe I said assign. To bind the name I to the object 1 and et cetera, right? Of course, you don't need the parentheses. You can just do it that way. So here, for example, there's a tuple, and there's a tuple, right? So you don't need the round brackets for tuples, in most cases. Sometimes you do. Depends on if it's confusing syntax, basically. T1 is equal to T2. That's interesting, right? So T1, I created a tuple. T2, I created a tuple. Are they equal? What does that mean? Well, the answer is two tuples are equal if their elements are all equal. So it marches through the two, both of those tuples, and does a compare on each one. And if it gets to the end of them, and it's been true all along, then it says, yep, these are the same. They are equal. Sorry, these are equal. These two tuples are equal because their elements are equal. Okay. Is T1 the same object? No. I can do count. I can do index. These look familiar from string. Yep.
Is it possible that T1 and T2 could return true?
I think it would be possible to change Python's implementation to do that without breaking any existing code. So Python could optimize that, I think. No, it is. This is, to use my earlier language, and I forgot to repeat the question. Could it be that this could have returned true? Yes, I'm pretty sure. My understanding of the Python language that they could implement, maybe in Python 3.8, they will implement an optimization where tuples that are the same should save memory. I doubt they're gonna because it'd take a long time to figure that out. It would slow down Python. But I think that no existing code would break if you did that. In practice, this implementation doesn't. It stores them separately. Now, is the one that's in this tuple and the one that's in that tuple the same? Yeah, they are in this current version. Okay, count index. Okay, this is pretty cool. See that star there? I've got 1, 2, 3, 4 things on the right, and I've got not just I and J, but I have N3, N4, and star rest. What happens here is Python does the assignment. This is called tuple unpacking, I think, or iterable unpacking. I can't remember the name, sorry. And now if I look at those, you can see that I've got a tuple. And the reason it's a tuple is because I just entered it as a tuple, right? So I put N3, comma, N4, comma, rest, so that's why it's showing it as a tuple. The point is, it's just 3 names. I'm just showing 3 names. What's interesting is the 5, 6 got put into a list, right? So this is a tuple. So the N3 is 3, the N4 is 4, and the rest is the list 5, 6. And that would be clearer if I did it as 3 lines. Okay, see what happened there? And how about here? What do you think will happen here? Could be an empty list, or could be an error. It's an empty list, right? Which kind of makes sense. Star, our intuition might be star means 0 or more. Okay, so this is very handy when you need it, and you can put the stars in the middle. The star, sorry, in the middle as well. Obviously, if you don't use star and it's going to fail. Okay, your turn to do exercises. I'll give you about, wow, this is a long one. But there's so much other good stuff. I'll give you like 3 minutes probably for this one. Okay. I'm going to start going through these already. Did anybody finish? Okay, yeah, good, one. Darn, I didn't start on it. I know it's kind of frustrating that I'm pushing so hard, but there's a lot of stuff. This is just, I'm take time later and go through it. So what I did a lot in the first half was let's understand how stuff's working behind the scenes. And now I'm sort of doing a lot more. Let's just explore and see all the stuff that's out there with some areas where I'm going back and saying, okay, but here's something you got to watch out for. And we'll see a couple of those in this section. So there's a list, m plus equal. Okay, int object is not iterable. That tells me that if it was, I bet I could do something. So let's try to give it an iterable. All right, so plus equal. Again, this acts a lot like m equals m plus 4 or 5. It's like a rebinding, although it actually doesn't do it through a rebinding. It does it because the plus equal I mentioned before, the dunder iadd method, actually changes the list. So this is basically this plus equal becomes a request to the list. Please take this iterable and add these elements, the 4 and the 5, to the end of yourself, is what's going on there. Okay, and it says iterable, it doesn't say list, so that should work. And that should work, and they do, right? Append is how you would add a single element to a list. And it only takes a single argument. So if I want to add 3 elements to a list, that will do it, but maybe not quite the way you thought, right? Append takes exactly one argument, and it appends that argument to the list. It did exactly what we told it, right? So it appended that single argument to the list. Del m square bracket minus 1. Is this a namespace operation? Not in this case. This is a request to the list, to the object that m is referring to, which in this case is a list. It's a request to that list. Please delete your last argument. Your last element. So change yourself in that way, right? And now I've got the m, maybe. And if I want to I can call m extend, and it will iterate over whatever I pass it and add those elements to the list. Lists take time to get to know them. Strings, yeah, if you're using lots of string stuff, do. Lists you're going to use all over the place in Python. Dicts you're going to use all over the place in Python. So get to know them. I encourage you, 2 months from now, put a note in your calendar, go read the section on dict in the standard library module and spend an hour and you'll go, oh, you can do that too? There's all this stuff you'll find. Okay. All right, see that list, 1, 2, 3, 1 through 7 and A through J. Is 10 in M? No. And then we saw the N not in versus not 10 in. Either of those works. Are 5 and 6 in M? Well, that's not actually what I asked. I asked, is the list 5, 6 in M? All right. What if I append the list 5, 6 and look at M? Now is 5, 6 in M? Yeah. What about this? Okay. And again, there's a couple ways that could have gone. Like, it's kind of I find this interesting because it's checking the type and the contents to see if that thing is in there. So in is kind of doing equality, kind of not. Anyway, there's the M. Okay, so let's keep going here. So now I've got M, which is 1, 2, 3, 4, blah, 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 and I've got N, which is 1, 2, and 4. So what will this do, you think? You'd think it might give us an error, right? Because the lists are the wrong length. But I'm not asking if they're equal. If I were asking if they're equal, it's going to say no. But I'm not asking if they're equal. I'm saying is M less than N. And what Python does is, oh, yeah, I'll check. I'll do what I can. I will check. Is 1 less than 1? Sorry. Is 1 less than 1? No. Okay, well, I'll keep going because I haven't answered the question, is M less than N? Check the 2. Is 3 less than 4? Yes. Oh, therefore, M is less than N. Okay, so you can do comparison of lists. That's how less than works on list and similar things. Sort of like string, right? Doesn't have to be the same length. Okay, this we saw. That's kind of fun. You can do a swap without a temp in between. We saw all these. I'll let you do the rest of those on your own. Splits, I showed you. I didn't show you join, though. Join, I don't think, is a method on string that basically takes all the elements of whatever you pass it and puts them together with a space in this case, or with a comma space, or with a whatever you want, or with nothing. If you just want to concatenate a string, this is the fast way to do it. Fast as in performance. Okay? You can build them up, but it's creating a new string every time, whereas this one doesn't. It goes down to the C level where Python implemented this and goes, oh, I can take that list in memory and just stick it in very fast into a single string. Okay. Sort is a method on list and some other objects. It returns none, but it asks the list to sort itself, and it does. Reverse is also a method, returns none, asks the list to sort itself. Okay? If I take that list, M, and I call sort on it with reverse equal true, okay? So this probably looks similar to sorted and reversed with an ED on the end, but they're not. These are methods on list. Sort and reverse, sorted and reversed are functions that you pass an iterable to, and they return something, either a list or something that can be turned into a list, an iterable. In this case, we're calling methods on the list. So if I do this, what's that going to do? This string will get passed off to list. Sort will be called on the list. And sort does what? Sorts the list. Asks the list to sort itself. And what does sort return? None. And none, does none have a reverse? That's right. And so let's see if the error says that. None type has no attribute reverse. Right? And these are intentionally, the behavior is done this way to make sure you don't mix them up. Whereas sorted, the function is not a method, right? So there's a sorted function. It's not a method on list. But it is a function that you can pass any iterable to, and it sorts it. It gives you back a list which is sorted, the sorted elements of whatever you pass to it. Okay? Okay, and that works okay. So here's months. Month 0. Try it again. Here's months. Month sub 0 is March. 3 is June. Minus 1, minus 2. This is called a slice. This specifically is a slice. Python actually sees that and creates a slice object. You can create them yourselves with the slice function, which is handy occasionally. And what it does is it says, please return me a list containing the elements starting at 0 and stopping before you get to 1. So this is going to return me a list of how many elements? 1. And it's going to return me a list or just a string? Returns me a list. Or stop before you get to 2. Element 2. So March, April, but not the third one. All right, let's just start that with January. So what will this one do? Remember the list is March, April, May, June, July. So it's going to give me March, April, May, June, and stop before July, because M minus 1 is, or months minus 1 is July. And what's this one going to do? Who thinks error? Come on. Who thinks it'll give me the whole list? Yeah. It could go either way. This is what it does. Again, what I'm showing you these things for is not to say, isn't Python weird? It's like, no, Python chose this way of working. And once you get to know Python, there's a lot of consistency in lots of places, right? So once you've seen this and a few of the other things, then I can show you other code, say, what do you think this is going to do? You say, oh, well, given what I've seen before, it's going to do that. So it's consistent in the way it treats things. There's lots of empty cases and optional arguments, et cetera. Okay, so what's this one going to do? I didn't say stop before minus 1, so it's going to go all the way to the end. just like this one did. Oh, by the way, again, if you read this as start at element 0 and stop before you get to 100, then it feels okay. Because it did, it stopped before 100, stopped at the end of the list. Okay, so this one is just going to return a copy of the list. Not the same list, a copy of it. And that's one of the three ways you can copy a list are that, and that. So if you need a copy of a list, any one of those works. Oh, look, copy works on tuple too. Where does it work? It actually works on byte array, dict, frozen set, list, and set. Those are the built-ins that have a copy method. Okay. March, April, May, June, July, months 2. Is months 2 equal to months? Yes. Are they the same? No. All right, remember, let's delete months 0, and of course, months sub 0, we're going to drop March from months, and months 2, it changed the list months, right? But months 2 was a different list. So this should all be pretty clear. Okay. I can do this. All right, I can change elements in a list using, just like I used del and equal before. I can append August. If I want to change August based on what it is currently, I have to do this, right? Like I have to pull it out, create a new string which is capitalized, put it back in. Okay. Yep. No, I'm almost, no, it's not. I'm 99% sure. No, I'm sure. Prove me wrong. Okay. I did that already. So del months 2, this is how you delete an object at an offset in a list, as opposed to remove. Remember, remove says go search for that and pull it out, drop it from the list. This one says go find element at index 2 and delete it, and it just looks back together. Lists are very efficient in Python over a wide range of use cases. So they're good for short ones, long ones. They sort of, when they get to a certain point and you have to grow them, they sort of grow a lot as opposed to growing a little bit at a time. So they work well in lots of situations. There's a nested list, a list of 2 lists, and you can access the elements that way. You don't see that very often, especially because places where you would want to do lots of nesting of big lists, you're probably using NumPy or pandas or something. All right, here are exercises. That I think I'm going to give you 1 minute for. Yeah, because only the first one's really that interesting. Okay, so these exercises or teach you one new thing here. M sub 1 equals 1020. We've seen that before. We said change the element, list, please change your element at index 1, replace it with the following object. So this is going to create a list within a list. Right? So let's put it back to 0, 1, 2. So you can do slices and assignment, and this says change the elements of the list starting at 1 and ending before you get to 2, which is the element, which is the 1, and replace them with these elements instead. So that's the way you can splice a list. Okay, so that's quite handy. This here you can explore later. It's just there's things you can do with the range. Range is a built-in function that returns an iterable, and you can use it to iterate over, well, an iterable over numbers. Start at 10, stop before you get to 20. Same thing, but count by 3s. Count by 10s from 0, stop before you get to 100, right? You can step backwards instead of, so it's the stop, the start, and the step. Notice that with, I didn't actually show that. I should show you. If you only give it one argument, it assumes you mean the stop, and start is 0 is the default for the start. If you give it 2, then it says, you mean start at 10 and stop at 20. That's kind of unusual, but intuitive. And here, what's going on here? Here I'm saying, give me a list from 0 to 99, and then do a slice, which is starting at offset 100, counting by, stop before you get to as far as you can go, and instead of, and here we're doing a step as part of the slice instead, right? So this is going to give us, this one's hard to predict to get right. I don't think I will get it right. It's going to start at 99 and give us 89 all the way down to 9, maybe? Yes. And this one's similar, right? Start at -1, which means start at the end. Stop before you get to the element at offset 1, which is the number 1. 0 is going to be 0. And count by -1, and count by 10s. Okay. So slicing and indexing work on strings and tuples too. So all this stuff, all this fancy stuff in here, you can use on strings and tuples, but you can't change them, of course. Okay. So range 8 gives me this range object. I can create a list by doing a for loop. You haven't seen a for loop before, of course. Most of you have seen a for loop, but this is the way you do a for loop in Python. You do for, name a variable that's going to get bound to each of the elements in range 8 as the for loop iterates over that object, right? Think of range 8 as a list, and that's the easy way to think of it. It's actually a little bit more complicated. It's an object that every time for loop asks for the next one, it gives it the next one, but it only computes it on as requested. And then for each one, append I to the list M. And maybe I should show what M is here. And we get that list. This syntax is called a list comprehension. And the nice thing about it is, well, one, it's a little bit shorter code, but much more important, and this is the way I suggest you think about it, it's a declaration of what you want, not how to get it. And that's part of why it was adopted as a feature in Python. So it's similar, though. We define, in a sense, we're saying for E, it's the same, for I in range 8, for E in range 8. I should change that to I. And then what it does is it evaluates the first expression before the word for, and whatever that evaluates to becomes the element that gets added to the list as it builds the list. So it does that several times. And so this is just going to give us the same thing we saw above. But I can have other expressions, right? I can have 2 times E. So now I'm going to get 2 times 0, 2 times 1, 2 times 2, all the way up to 2 times 7, right? Or I can do 2 plus, which will give me 2 to 9 instead of 0 to 7. You can also have an if statement in there that says, but only put only put this expression in the list if this value here if that value is the true, right? And then it's just going to skip the even ones. Sorry, skip the odd ones. It's going to only include the even ones, right? Put that in the list if it evenly divides by 2. And you can have other stuff here, right? Here's an F string. A big, long, complicated F string, relatively speaking. It's bigger than the rest of the list comprehension. So it's going to put a string in and evaluate that each time for all of those 8. And I get that. And I can combine the complicated string and an if statement. Right. So I think this is easier to read than that, and cleaner and nicer. I think this is maybe not as clear as a for loop. So use list comprehension sparingly. Right? They make sense in some cases, but not all cases. So you notice here I didn't use the E in the expression that gets evaluated to put stuff into the list. So it's just going to give me 8 spams. Right? So again, unusual use case. I think this is weird. I would look at this code and say, is that what you meant? Yeah, well, do it some way that's clear that that's what you meant. Anyway, okay. Oh, and you can do these nested, by the way. You can have spam for E in range 8, or you could have spam, comma, E2 for E in range 8 for E2 in, I've never seen a nested list comprehension that made sense to me easily. So I would usually avoid that too. Anyway, all right, let's create months. Give a name months, bind it to a list of 3 tuples, which are in alphabetical order, April, February, March. They're not in month order, and they're not in order based on the number of days. There we go. So if I sort these things, as in create a new list which is sorted from the old list, I get the same thing. If I reverse it, yeah, that's fine, this all works. And you notice the way it's doing that sorting is it's comparing the tuples, right? And you know how it compares tuples. It compares the first element, then the second, then the third, right? All right, let me show you some cool stuff in Python. Months sub 2 gives me 0, 1, 2. It gives me March 3/31, which is why it's right there. All right, so let me define a function called getIndex1, which which accesses the element at whatever you pass it, it accesses element at index 1. So if I call getIndex1 of months, well, here's 0, and here's 1. So it should give me back that tuple, right? So I've defined the function. Here's how you define a function in Python, by the way, in case you've never seen it. Right? You choose the name of the function. You choose to name the arguments, whatever you want. You use those names in here. You return something when you're done. Okay, so let's do a getIndex1 of months and hope we get the February tuple back out. And if I do getIndex1 of months sub 2, this is just to make you think, right? So if I take months sub 2, which would be March 3/31, and call getIndex1 on it, I should get back the 3. Right? Okay, so Python, it's very common in Python to have functions that return functions. So at the top of your my screen is the easy way, is the straightforward way to define the function getIndex1. At the bottom here is I import the operator module, I call its itemGetter callable, which is a function, and I pass it the number 1. It returns me a function that does the same thing. Okay? And for some of you, if you're like me, having worked in other languages, this is a function that returns a function? That's really weird. But once you get used to it, it's really, really powerful. And so if your brain hurts a little bit for some of this stuff, that's normal. Keep trying, and pretty soon you'll become fluent in it, and you're like, oh yeah, this is way easier. It really makes sense. So I've just created a function, and I bound that function in the namespace to this, right? So it's kind of funny because I take a function object and do an assignment of the name. I bind the name getIndex1 in the current namespace to that new function object. Well, that's exactly how the def works. Def basically evaluates some code, creates a function object, and then adds the name to the namespace. Anyway, little digression there. So now if I call get index 1 months 2, I'm going to get the same thing, of course, as I did earlier, 3, and there's the 2. And what is index 1 of these tuples? It's the number of the month. Now here's the trick, is I can, oh no, wait. Yeah, so that's just the third one. So all I've done here is instead of having get index 1, I just substitute the item operator item getter 1. So here's this call. This is a hard one to read, eh? Let me walk it through you slowly. Look at operator. It's a module. Access the object, which is item getter. Look at the one, create an integer object, pass it off to this function. Whatever it returns, call it, because it's a function object, I can call it. Passing it, well, that thing, right? So that's what's going on there. And again, hard to read if you haven't seen it before, but easy once you get used to it. So it works. It returns 2, meaning months sub 1, which is February, is month number 2. Okay, so here's the way you might see it is, again, these are the same, but this is a common idiom. You'll often see, I want to sort this based on a certain key, right? And so what this does, this is called a callback. So I pass sorted, you saw the sorted months reverse equals true. Well, here I'm saying, don't sort month in reverse order. I'm saying pass it by using as the key. When you want a key, sort function, when you want a key to figure out how to compare two things, to figure out the key for the sort, what order they should go in, call this function. So every time that sorted gets a list, it might be huge, and it goes, okay, which one goes first? We'll have to compare all these. And it's doing all these comparisons. Which one's less than, which one's greater than, which one's less than, these two are equal, etc. Every time it does that, it looks at the objects. If key was passed in, it calls that, it takes the object, passes it off to whatever operator item getter 1 returned, which is a function, and that pulls out of the object the piece that I should actually, the sort function should be comparing. Okay? So that's how you can sort on something other than just the straightforward order of a tuple. All right. So if you're brave, don't snicker at your neighbor. How many of you found that confusing? Oh, come on. I don't believe you. Okay, I would have. Yeah, no, it's hard to get used to, but this is functions as first-class objects in Python, one of the most very powerful thing. Okay. Yeah. I'll give you 1 minute for this one. For the exercises, go ahead. Okay. I'm going to keep us moving along. We're in the home stretch, less than an hour. I think we only got 40 minutes. Is that right? Thanks. Thanks for checking my math. Okay, so this was straightforward. Straightforward, I think. Oh, yeah, nested. Yuck. It's getting hard to read. Don't do it. Enumerate is something that, so in Python, in many languages, you need to create an index value and enumerate and count starting at 0 in order to do things to a list. Python, you don't need to do that. So enumerate, you'll often will find being used when you actually care as you walk through a list, what element am I at? But you can see what enumerate does is it takes an iterable and it returns, for each of the elements of that iterable, it returns a pair, which is the offset into the iterable and the element, the offset and the element, right? So here we get 0A, 1B, 2C. So it basically, instead of returning A, which it would have without the enumerate, it now returns the tuple 0, comma A, right? You can do various things with that. Zip is sort of like a zipper, but instead of like this, it's sort of like that. It's instead of like this, it pairs things together. Whatever you pass it, 2 or more elements, it takes them all and puts them into tuples. So what this is going to do is create a list of Jan 1, Feb 2, Mar 3, right? And I threw in the split just to, keep things interesting. What's this going to do? I've got 3 months and 4 month numbers. I know you can do it. Who thinks it's going to work? Raise your hand. Who thinks it's going to give an error? It works. Weird, eh? But again, once you get used to this style of zip's going to stop when it gets to the end of one of them, it's really handy. There are lots of places where you don't need lots of places where what would have been 2 lines of code or an if statement is just, well, just do this thing, and for the default empty thing, it'll do the right whatever. That wasn't very articulate. Sometimes you actually do care, and you want something else, so you can call itertools.izip longest, I think, and supply default. Well, let's do the opposite. Anyway, so that's a little surprising, but that's the way it works. All right, and these are just different ways to do fancy. All right, and then I told you to do that, and I'm not going to show you how you know how to do that. So on to the next section. Dictionaries are amazing. What I mean by that is they're really fast in Python, and they have order and lookup time. And over the years, if you program in Python that long, you will find yourself using dictionaries for more and more solutions to problems. And at first you're like, oh yeah, does that work? You'll see solutions to problems where dictionaries, they're really, really powerful. Anyway, to explain dictionaries, I hinted at them over here. It's key value pairs. So let me start by explaining dictionaries by reminding you at a higher level of abstraction, sort of mathematical. A list is a mapping, a one-to-one mapping from a domain to a range. Anyone remember this from high school math? If you didn't take any more than that. And the domain is 0, 1, 2, 3, etc. It starts at 0, counts up. So it's ints to something. So that's what I mean by here, from int to anything. You can have anything in a list, right? So here's an example. And I'm going to take January, February, March. I'm going to add none to the front of it. Or if you have a newer enough version of Python, you can just do that, which is kind of cool. Another example of this unpacking. And now, conveniently, index 0 is none. Index 1 is January, which we call the first month of the year. February is the second month, and March is the third month. So that's why I did that. Right? So now I can say, what's the first month? January, second month, third month. A dictionary, you don't need to go to that hassle. You can just put in 1 maps to January, 2 maps to February, 3 maps to March. I didn't have to put in some weird none. So now I have something like that. Right? Now I can just say, tell me what month number it is. All right? Or I can do that and get the reverse. Right? So all I'm doing here is n, comma n, m. You notice I have for n, comma m, and then I have for m, colon n. So this is a list. This is a dictionary comprehension where, similar to a list comprehension, uses a curly brace instead of a square bracket, and instead of a single expression, has 2 expressions with a colon between them, because that's the syntax of dictionaries, as you see down here. The key value pairs are separated by a colon. So same idea, slightly different syntax. Play with it later, and you'll get used to it. So here what I have is I've turned that list into, well, that list of, the list way up there in cell 1 into mapping from month to month number, okay? So now I can say, well, what month number is January, February, March? And it just works, right? April, key error. That one's new, right? Key error is when you try to access a key in a dictionary that isn't there. So I can add it, similar to, same syntax as list, except instead of giving it an int, I'm giving it almost whatever I want. I'm giving it a key, and it puts the key value pair in. So it inserts April 4 as a key value pair, and then the lookup on April, that's the part that's just really fast. No matter, a list of 1 million, and it would look it up super fast, because it uses hashes. Go read about it. And then once I've done that, I can look at it. So in Python 3, if you're using an older version of Python, like 3, I can't remember. I think it's 3.6 is when dictionary order of insertion was preserved. So in this case, you notice when it prints out, it prints it in the order that they were put in. I added month April last, and it shows up last. Before 3.6, no guarantee what the order was, because that wasn't the purpose of dictionaries. It was not primarily about ordering. Anyway, so you can use in, and it looks for the key. If you want to look for the value, it's a lot slower. Month to int, if I do a del, it's going to delete the one at that offset, is the terminology I use for a list. In this case, delete the one at that key, or that key and its value. The key value pair gets deleted, it's gone, it's not in there anymore. Okay, let's do a few things fun with dictionaries. Here's an empty dictionary. For C in Mississippi, letters sub C equals 1. So it's going to add keys M, I, S, and P to the dictionary multiple times, except the M, it'll only add it once. It'll keep overwriting some of them, and each one will have the value 1, right? All right. So there's the dictionary, and those are the letters in Mississippi. Right? So there's an example, trivial, of, okay, I've got this huge list. What are the unique keys of it, or something? What are the unique values in on this list? A dictionary is a quick way to do it. You can also do this. Dict dot. So dict dot, what I'm doing here is dict is the type. From keys is a function that's in that. So I'm not calling a method on a dictionary. I'm calling the function that's in the dict that's sort of hanging off the dict type. And I'm saying, create me a new dictionary from the following keys. It's just going to create a dictionary with, actually I should show, yeah, okay, with those keys, M, I, S, and P, and they all have the value none by default. You can add a different default in here if you want as a second argument. Okay. And here's another way to do the same thing, where I'm using a dict comprehension. Right? Okay, let's import collections. Remember that int returns 0 if you call it with nothing. So now I'm going to create a default dict. Default dict is a type that basically it's a dictionary that to start with is empty. But if I access an element that's not in there, it doesn't fail. Instead, it goes off and calls whatever function I pass to it, puts in whatever that function returns, and gives it back to me, remembering, oh, all right. And now it knows that M is 0. Right? So now I can do this. I can actually pull the value out, add 1 to it, put it back in. Even for letters like S that aren't in there yet, it'll assume that there was a 0 in there. Oh, so now I actually have a count of the letters, right? How many S's are in Mississippi? There are 4. And I can look at dictionaries have .keys, .items, .keys, .values, and .items. The keys give just the keys, the values just give the values, and the items give the pairs. Okay, there's also a collections counter thing that's a lot easier, so you could just do that. Interestingly, dictionary views are these things that keys, values, and items return. You can iterate over them and do membership tests on them. So I can iterate over them. How many, find the highest number of, it's hard to describe. Mississippi has letters. What's the most common letter? This doesn't answer that. It's how many of them are there. The answer, there's 4. There's more than one letter that have 4. Okay, and is Z in counts keys? No. Okay. There's also a set type in Python, which is basically implemented, and think about it a lot, like it's the keys. A set is like a dictionary with only the keys, where the values are ignored. They're not even stored in the dictionary, right? So the set of Mississippi gives me that. You notice there's no ordering on that, by the way. It doesn't order at M and then M. Like the set order doesn't matter. Assiniboine is the river that I live close to, and it also has lots of I's and S's and N's, which is nice. So I can do things like, what are the letters in Assiniboine? I can do subtraction. I can do intersection. I can do or, right? I can do equality, of course. So lots of stuff you can do with sets, which are nice. And you can do those straight on the views that dictionary gives you back. You can actually do set operations on those directly, which is very nice. That doesn't do what I expected it to, because I didn't give it what I thought. Sorry. Because what I wanted here is probably these sets. Doesn't matter. Trust me, it works. We'll keep going. No, trust me, this doesn't work because I did the wrong thing. But what I'm pointing out is you can do set operations on the keys. The problem is that count keys has it. Oh, because count is, I don't know why it didn't work. I'll figure it out later. Okay, so I said at the top here, you can put almost anything in a dictionary as the key. You can't put everything. Hash is the way they work. Hash basically returns a unique value for a string. Well, very unlikely to. Well, so it's the way that dictionaries are fast. Trying not to get distracted into those digressions. And you can take a tuple and hash it. You can take a list and it says you can't. You can take a list and hash it, and it will tell you it's unhashable. And the reason it's unhashable is because you can change it, and that would mess up the dictionary lookup if you changed it after you put it in the dictionary. So that's why this is a valid dictionary, and this is a valid dictionary, and this one doesn't work, right? So if you really need to create a dictionary with lists you know you're not going to change, you can create a subtype of list and do stuff. But basically, the things you put into a dictionary, their hash can't change once it's in the dictionary, or it will mess up the way dictionaries work. Okay, this one, I'm going to just do a couple of these. I'm going to do, and I'll let you do the rest later, right? So pop and pop item. So a dictionary, once you put stuff in there, you can access keys and values and items. Pop says, go get this one, take it out of the dictionary and return its key, its value. Take this key out and return its value. Pop item just says, well, go get me one and return, pop it out and give me some, similar to list pop, okay? And this one, I'm going to skip, and the set stuff I'll let you play with. And I will just move on to this dictionary example. I like this example. I hope it's helpful because it, the fact that functions are first order objects, they're first class objects in Python, that and some other things about Python blur the line more than usual between code and data. When you write Python programs, often you'll have stuff in code that looks, in a data structure that looks like, that is code. And this shows you an example. And when you first see it, it kind of looks odd, but you'll quickly, over time, you'll learn, you'll say, oh, that thing I wrote in that other language 3 years ago that was like 500 lines of if-else statements, I could have done it in a dictionary. And here's an example. So I'm just going to, it's a little digression here to, let's create a calculator. 7 plus 3. It's a calculator that handles 3 characters. You can only give it 3 characters, a string of 3 characters. So I'm going to start by reminding you that, operator that had item getter has a bunch of other things. It also has all the operators, like the plus, but as names to objects that you can use as a function. So I can call operators add function, pass it 2 arguments, and it's exactly the same as if I said 7 plus 3. Well, why don't I just say 7 plus 3? Because I don't have to write an if statement. That's why. You'll see why. Right? So that works. I'm looking for puzzled looks. I don't see too many. So here I'm going to do the unpacking of my strictly 3-character calculator input and get 7 and a plus and a 3. I'm going to turn the left-hand side and the right-hand side of the plus operation into ints. So I get 7 plus 3 with the 7 and the 3 as ints now instead of strings. Because then, and then I'm going to turn them around. Let's put the operator first so it looks like the order that operator add needs. Now I've got the plus corresponds to the operator add, and it passes the 2 arguments in, right? So that works. So now I do this. Right? So this is a dictionary where the keys are a single character string, a string of length 1, and they happen to be the operators plus and minus, and the value is a function. So now, and again, some of you go, this is obvious. Others will go, this is really hard to think about. Ops sub op is look in the dictionary for the key plus, for example, and whatever you get out, call it. See the parentheses that's come right after this. Actually, I put a space in there, but the point is, this is, if you have an object and you put parentheses and some things and close parentheses, that calls the object. So it's going to call the function. So when I call the function add, I'm going to get 10. So here's my calculator. I define it taking an expression of 3 characters. I do the same lines of code I just showed you, and it returns the call of the function it got out of the dictionary based on the single character string, calls it with the arguments it got out of that single string. Oh, maybe I have to define it first. So now I can do calc 7 plus 3, calc minus 5, right? So it does math, plus and minus, but it doesn't do slash. So the way you may have implemented something like this in a class long ago or on your own long ago would have been an if statement. If it's plus, if it's a slash, do, divide, and you have all this stuff. Here, if I want to change that, I just add something, and it works, right? And again, it's hard to imagine here, but when you're doing something where you've got lots of options, often the data structure of code that holds code in the names in the form of functions is a lot easier to work with and a lot easier to maintain and reason about, et cetera. Okay? Okay. Anybody know what this is going to do? What? Syntax error. Yes. Oh, I'm wrong. It's an indentation error, similar to a syntax error, right? So Python indentation matters. You probably know that already, but there's proof. Right? Here's an example of a for loop. So you have while and then an expression that evaluates to true or false, or is evaluated as true or false. And we'll see later that some things that you might not think you could put there, you can, like an empty list is false and a non-empty list is true. Anyway, we'll see that in a moment. So it basically, the colon starts a block. You put 4 spaces. You can do other numbers, and you can use tabs. Don't always use 4 spaces. It's what everyone does almost. And then it executes these 2 lines of code, and then it goes back up and says, well, is I still less than 5? If true, it'll keep going around the loop. And as soon as it's false, it skips it to the end. Okay, so let's see if this works. Yes. The genie's out of the bottle. Python's doing what we want. Here's an example of an if statement. If, elif, else. Just does some printing. Here's a for loop iterating over a string, which you've seen pieces of before, but here's typically how it would look. Here's a nested for loop, right? And again, it knows when does it, you can't see here, but it ends the block when it gets to the end of the file, like in this case, or when it gets to an unindented line. So that's how it tells. So it's very clear, but unusual if you use the curly braces. Let's create a little dictionary. so you can see what it looks like. Here's a simple for loop over a dictionary. So here, key and value for D in ED items. So this is how you would iterate over. So you notice here, K comma V, this is a tuple. This is doing name tuple assignment. So items is going to return pairs. Half the pair gets into K and the other in V. So K is bound to one, V is bound to the other, right? And I should do an S string for that. All right, here's loops can have a break, which says if you get to this, so here it's going to count, this for loop's going to keep going until 1,000, unless it hits a break, which it's going to because we have an if statement in there. So a break is the way you stop early, an exit, stop a for loop early. Continue is how you stop partway through the block of a for loop and go to the next iteration around the loop. Okay? I can't remember why I have that one in there. Well, you can have a pass. It just passes the empty. It does nothing. So apologize for not remembering why. And these, 20 minutes left. I'm going to keep going. So is this going to print true or false? I told you 2 minutes ago. Well, it's never going to print false because I didn't say to print false. Sorry. Is this going to print true or not is what I should have said. All right. And the answer is it's not going to print true because in Python, an empty list, an empty dict, an empty set, the number 0, the number 0.0 in float, anything, I can't remember what else, anything that defines a dunder bool method, and there's something else with non-zero. That might have been a name change. Anyway, the point is there are things that are kind of falsy, it's called. And that's confusing if you're not used to it. So this one especially, right? Here I've got a list that only has something that is falsy, because none is falsy. If you say if none, it won't do it. Although, as I mentioned earlier, in a function, you would often say if none, if argument is none, because you care what they passed. You don't, I'll explain that later. So this really looks like it ought to print true, but does it? Well, no. Oh, it does, because list is non-empty. Non-empty. So it doesn't matter what's in the list. As long as it's not empty, it's going to say, yeah, that's true, and then therefore I will execute that. So you can see that bool of that and that is why it did that. And here are some other examples, right? Bool of an empty string is false. So an empty string is falsy, truthy and falsy. I've only ever heard those talking about Python. How about bool of false? It's true because it's a non-empty string, and we don't need to convert. Like int, it did a conversion. It's not going to convert the string false to false because there's no point. So dictionaries, if you iterate over a dictionary without the items, it actually just iterates over the keys. Okay? And you can do that. And I'll skip those. I will skip all of those and let you do those. Okay. So let's talk a little bit more formally about iterables and then just explore them a little bit. So what happens in a for loop is whatever the expression is evaluated, right? So I might have some complicated expression as opposed to just a single name that refers to a single object. It gets evaluated, and that's an iterable. We call that an iterable because it is able to be iterated over. It then calls the iter built-in function on that object, and that produces an iterator. And the next function is called repeatedly on it through the dunder next method. And then eventually it raises a stop iteration, which is an exception, but it's a special one that's actually not an error. It's just something convenient as like when you're, like think of a function that calls a function that calls a function. In this function, I might have a return and a return and a return, but somewhere in there, if I have an exception, it might not be caught in that function, might not be caught in that function, might go all the way back to the third one that called, right? So exceptions are another way of returning a value, but they go through a different route. They don't just return to the caller as a function does. They return to whoever catches the exception further up. And stop iteration is used internally by Python to implement for loops because it's convenient. Okay. what does iter do? Well, it looks for a dunder iter and calls it if it exists. If it doesn't, then it calls dunder get item. So lists are iterable because they have get item, which is what the square brackets do. Anyway, that's a high level and kind of dry presentation. But let's just play with it. Remember this? I said you have to pass it to a list. Well, we don't have to. We can remember, like, I saw what the object is. Let's just grab the object here. And actually, maybe it'd be easier if I here did. Let's just look at it there, right? And its type is, doesn't tell me much more. It has some arguments, including a dunder next. So I can call it. And what do I get? Well, it's a list 1, 2, 3, 4, 5, reversed. Well, no. It's something that can iterate over a list in reverse order. So behind the scenes, it's actually storing the list and then marching through it backwards because it doesn't want to, because it's better to do it lazy. Do the evaluation later, and there are times when that saves memory or CPU. Okay, so I can call it again. So again, this is the built-in that you can call without the dunder iter. So the first is a method on IT. That's what next calls. So I can call it again, call it again, call it again. This is how the for loop works. It's kind of nice to know that. And by the way, if an iterator is exhausted, is the term, then when you call next on it again, it should still raise the stop iteration. So if you ever write your own iterators from scratch, it's easy to do. Make sure you handle that edge case correctly. Of course, here's the normal way we would write it. Right? We just do a for loop. We don't need to use the next. It's the for loop that did the next for us. And when it got the stop iteration, we never saw the stop iteration. It just exited the loop. Okay? A list object doesn't have an iterator. But if I pass it to the iter function and get back an iterator, take the iterable, pass it to the iter function to get an iterator, it's got one, right? And it does similar kinds of things. And this is the way it works. So get item 0, remember list here is 1, 0 through 5. Get item 0 is what actually gets called when Python, or equivalent to when Python sees the square bracket, right? So get item 0 is the same as m square bracket 0. Think of it that way. I can get the next one, I can get the next one, I can get the next one, I can get the next one. Sorry. Just a note to myself to remember, I might change that slightly. Okay. So here's a list comprehension. It is of type list, as you can see. This looks almost the same, except it uses round brackets instead of square brackets, also known as parentheses. All right. Ooh, generator object gen expression. This is called a generator expression, similar to a list comprehension, similar to a function, which is a generator, which we probably won't have time to see. And its type is generator. Does it have one of these? Yes, it does. It has a bunch of other stuff too, but it's got in there, oh, it's got GI code, frame, running, yield, from, close, send and throw. Those are interesting things you might find out about if you go read about generators. So I can call next on it, and it raises a stop, right? So this is an iterable. So this thing is iterable, and here we're just exploring how the iterator protocol, the iterator protocol uses it by calling next, and then it raises the stop iteration. Okay. And I'll let you play with this on your own. How much time we got? 12 minutes, right? Anybody tired? Oh, I'm getting tired a little bit. Well, if you're not, let's just keep going for 3 hours. Okay. So I'm going to show you one more section probably, which is this one. I don't think I'll get to the next one, which talks about classes a little bit. And then there's another one after that, which has some exercises you can do on your own. So This is all great to have, one-liners, but this is not the way we actually code. So I thought, let me tell you a little bit. So if you're going to write a script or module in Python, if it's a script you're going to run, put that as the very first line. Even on Windows, it works if you're using the Py tool. If not, on Windows, you can use suffix.py. There's also a pyw that works for reasons of whether or not it shows the console. When it evaluates the script, when you import a module or run a Python script, it compiles it into bytecode on the fly and stores it in a folder that looks like that. So if you see those lying around, that's what's going on. Only compiles it the first time it's used until you modify the PY again. Always name your scripts with lowercase and valid Python identifiers, because then you can use imports on them later as they change and grow over time. So what I'm going to do here, that you can do too, is I'm going to write that file, which happened to already be there, which is why it warned me, using this special syntax. If you unpack the zip, you should have this file in there anyway, so if you're not running Jupyter Notebook, you'll be fine. Okay, import play 0, what's that going to do? Which one? Which error? No module, close. Oh yes, totally right. Not module not found error, right? So that's what import, when you try to import. So what it did is import took this, not string, but identifier. So it's not a string literal, it's an identifier, which is a valid identifier, but it turns it into a file name, and it goes looking for a file called play0.py, and there isn't one here, so it failed to get it. It actually can look in .py files, .pyc, .pyd, in zip files that have things in it. All sorts of things is where it can actually look, but typically it's looking in play0.py. Can't find it. So this one, so here, this is interesting. When it loads this code, it runs it. So x equals 3, y equals 2, and then it should do a print. I only noticed last night that this is not going to print. It doesn't work with Jupyter Lab, which I was using last night. Jupyter does this correctly. Jupyter Lab, I think, is either a bug or they just didn't do it. I don't know. So you notice that it printed module loading when we imported play 1. All right, and that's why I have these comments here, is because it was doing different in Jupyter Lab, which is the newer version. So if I import it again, it didn't print that, right? So the first time it loaded the module. This print statement was executed, as was the assignment, the y equal and the x equal. But when I load it, when I do an import and it's already been loaded, it just says, oh, I've got that already, and it doesn't reevaluate the code. It doesn't recompile all that and get the function definitions or whatever else is in that module. It just uses the one it already has. If we look at what's in that module, what attributes that module has, well, it has the x and has the y, right, which are at the global module level up here. It has some other stuff like the file, which is where it came from, package, spec, etc. So we can access those attributes. And if they don't exist, it will say not a name error, but an attribute error. Module play has no attribute. I can add them. Oh, anybody make that? Anybody get nervous seeing that? I can just take someone else's module and put stuff in it. That's kind of weird, but you can do that in Python. You probably don't want to. So we trust you to do good things with Python, not write crazy code. And then I can access it. And now if I look at play 1, there's the Z. I can change the name and just give it so all this does is it does the import, which means it goes and finds that it's already imported it, and just inserts a new name. So what this does is it says, when you go find whatever that module is called, use this as the name in the current module that is added in the namespace, as opposed to using the name I gave you, which lets you go find the file. And I can look at that object and see that it's got the same attributes. I can delete that. And of course, these are just two different names, and so neither of them have the Z attribute or the Z attribute now. If you really need to reload, which occasionally is handy when you're doing development, for example, you can import lib, and it tells you what you can do. And so you can do a reload of it, and you notice it says module loading. So if you want to force a reload, that's the way to do it. It won't automatically go look. Every time you do an import, it's not going to go look to see if it changed on the disk, because that would just slow Python down with not much value. It's pretty rare that you need to do a reload. It's almost never would you do this in production code or regular code you're running. It's almost always you would only use this when you're doing some development. Okay, So let's do this and import SNT. So here you can just import some of the names from a module. So I did from play2 import st dir play2. You remember what this is going to do? I only imported SNT. I didn't import play2. It's a name error. It looks for play2. Couldn't find it. Okay? But it does find SNT. Right? So just helping you think here about what the, again, focusing on namespaces. If you understand how names work, everything's easier in Python. All right, let's look at a bigger one. So this is a bad idea to actually have when you write a module, it should never do anything other than define functions, define classes, define constants, and maybe import other modules. So putting a play right in here is a bad idea. This, on the other hand, is allowed. Okay? So what this does, and this is the right way to do it, and it looks weird, I know, but it's using that dunder name attribute of modules. Basically what this does is, if we are running the play module, Python space play3.py, it'll do all these definitions, and then this is the only code that gets executed. And if we're calling it by typing Python space play3.py, then the name will be main, and it will execute test play, or whatever we want it to execute. So that's the way you write a script or a program that top level runs. If we import this module, and it won't execute test play. It'll only define functions and the global player. Okay? So let's see if that's straight. Oh, I've used the import star I told you not to use. Right? But you notice it didn't. Oh, sorry. This really needs to have a. I really want to prove it. I should have a print in there. But trust me, it didn't actually run test play. It defined it, but it didn't run it. And you can see that those are there. Players, one, and there are the two functions. And their function names, they've got these longer names to tell you where they came from. Okay. 3 minutes. Function, there's a longer exercise in section 11 that I'm not going to do that talks about functions and lets you explore them more. Just some nomenclature. The signature is even, and if you want to use the precise terminology, n is the parameter, and 2 is the argument. Not a big deal, but when you're reading stuff, that might make things clear. Here's an example, example. I'm going to skip this and talk about generators. Last thing. So generators, I mentioned them in passing. We saw generator expressions. Here's how you write a generator function. So this is a function, but instead of having a return in it, it has yield. And what that does is, here's the function. It's a function, right? So if I call it, will I get 1, 2, 3? No, I get a generator object. If I pass that iterable off to list, it will get the 1, 2, and 3 and stick them in a list for me. Okay? Let's do it the way we saw a few minutes ago. There's the iterator. Its type is a generator, and we can call next on it. Right? So this function is something that a for loop can iterate over. Yeah, okay. So here's how you would typically call it. Right? So whether you call list 1, 2, 3 and it returns a list, or whether you call it and it only returns an item every time as it goes around the loop, that's fine. Like, yeah. So if you put a print statement right in here, in between these things, you would actually see the prints interleaved in here, because it actually puts the function on hold, and then it starts it again to get the next one. It starts it again until it hits a yield. Starts again until it hits a yield. So the for loop and the iterator are working interleaved. Okay, so here's a faster way to do, a simpler way to do the same thing, right? I could just, instead of yield 1, yield 2, yield 3, I could just do that. And same kind of stuff. All right, let's try factorials. Here's a way to do a factorial function. So let me call that, call that, call that, call that. So what if I pass this factorial generator which I should have named that in there. What if I pass the factorial generator off to list? What's that? I will run out of memory. I won't get a recursion error because I'm not doing a recursion solution. I'll run out of memory because it'll just never quit, right? So I'm not going to run that actually. But so what I will do is I'm going to create another function which just stops when the length of what it returns is past a certain length. There we go. Oh, nice. Okay, last thing. Here's a function that returns a list of even numbers less than 10. Here is a generator that on demand returns a list of, not a list, a sequence, an iterable of even numbers less than 10. Which one's easier to read? Which one's simpler? The first one, I would say no. At least once you get used to it. You don't have to do this thing. You don't have to do this thing. You replace, or you don't have to do this thing. You just yield. And it's simpler, right? So generators are nice because they're lazy. Some things you don't know when you don't want to compute all the factorials, but you might want to compute some. You don't know how many, so you just only compute on demand. Reading a file, you might be trying to read a file that's bigger than the amount of memory you have. Well, don't read it all at once, read it line by line. There's lots of places where that's true. Network traffic, same thing. And generators are important for async stuff. But they're also just easier to think about and read and write. Well, once you get used to them, they're easier to write. And you notice that the use of these two things is the same, right? For num and even ones, for num and evens two. Sorry. They do the same thing. And there's an exercise and some stuff with calls, and I'm out of time. And thank you for coming.